Have you ever sat in a quiet room, closed your eyes, and tried to locate exactly where you are inside your head? It is a strange sensation, a feeling of being a passenger within a vessel of flesh and bone, looking out through windows made of living tissue. We feel separate from the world around us, distinct entities navigating a universe of dead matter. We think of the cosmos as something out there, a vast and cold stage upon which the drama of our lives plays out. But this feeling of separation is perhaps the greatest illusion of all. The story I want to tell you today is not just the story of how the universe began, but the story of how it woke up. It is the story of how a cosmos of simple hydrogen and helium, governed by rigid laws of physics, somehow organized itself into eyes that could see, ears that could hear, and minds that could wonder. It is the story of you and me and every sentient being that has ever looked up at the night sky and felt a shiver of awe. To understand this journey, to truly grasp how consciousness emerged from the unthinking void, we must go back to the very beginning. We must return to a time before time, to a place before space, when everything that is, everything that was, and everything that ever will be, was compressed into a single point of infinite potential. Imagine, if you can, a darkness deeper than any night you have ever known. This is not merely the absence of light, for light itself does not yet exist. It is the absence of space to hold the light. It is the absence of time to measure the darkness. In this pre-cosmic state, the laws of physics as we know them had not yet taken shape. There were no stars to burn, no galaxies to spin, no atoms to bond. There was only the potential for existence, a quantum seed suspended in a void of nothingness. And then, 13.8 billion years ago, something changed. We call it the Big Bang, a name that implies a chaotic explosion, a violent detonation in the dark. But cosmologists tell us it was not an explosion in space, but an explosion of space itself, in a fraction of a second so small that our language lacks the words to describe it. The universe unfurled. It expanded from a point smaller than a single proton to something vast, stretching faster than the speed of light. This was the era of inflation, a moment of cosmic breath where the universe sighed into existence. During these first few moments, the universe was not a place of matter, but of pure, searing energy. It was a cauldron of temperatures so high that atoms could not exist. It was a sea of fundamental particles, quarks and gluons, colliding and interacting in a frenzy of creation and destruction. If you could have existed in that moment, you would not have seen anything. The universe was opaque, a thick fog of plasma that trapped every photon, every particle of light, preventing it from traveling more than a tiny distance. It was a universe of blinding brightness, yet it was also a universe of darkness, for there was no transparency, no clarity, only the chaos of extreme heat. For hundreds of thousands of years, this was the state of our reality. A hot, dense, expanding soup of particles, slowly cooling as it stretched outward. It is hard to imagine that in this chaotic inferno lay the seeds of your own consciousness. The electrons that now power the electrical impulses in your brain were there, dancing in the plasma. The quarks that would eventually form the protons and neutrons of your DNA were there, swimming in the primordial sea. Nothing was lost, and nothing has been added since. The universe we see today is simply the same primordial energy, cooled down and rearranged into more complex patterns. As the universe continued to expand, it continued to cool. The frantic energy of the particles began to slow. The chaotic dance began to settle into a rhythm, and then, about 380,000 years after the beginning, a critical threshold was crossed. The temperature dropped just enough, to about 3,000 degrees Kelvin, for electrons to be captured by protons. For the first time, stable atoms of hydrogen and helium were formed. This moment is known as recombination, and it changed the character of the cosmos forever. Suddenly, the fog of plasma cleared. The photons of light, which had been trapped, bouncing endlessly between charged particles, were finally free to travel. In an instant, the universe became transparent. A flash of light, the first light, streamed out in every direction, filling the cosmos with a brilliant glow. We can still see this light today. We call it the cosmic microwave background radiation. It is a faint hiss of radio waves that comes from every part of the sky, a ghostly echo of that moment when the universe first opened its eyes, scientifically speaking. If you tune an old television set between channels, a small percentage of that static snow is actually the remnant of this ancient light, the afterglow of creation interacting with your technology. But after this brilliant flash, the universe plunged into darkness again. This era is known to astronomers as the cosmic dark ages. There were no stars yet to shine. There were no galaxies to light up the void. There was only the expanding sea of hydrogen and helium gas drifting in the silence. It was a time of waiting, a time of deep, profound patience. Imagine floating in that endless dark. No sun, no moon, no distant points of starlight. Just an infinite ocean of invisible gas. It might seem empty, it might seem dead, but in the darkness, gravity was working its subtle magic. Gravity is the sculptor of the universe. It is the patient artist that takes the chaos of the void and shapes it into meaning. In the density of the early universe, there were tiny imperfections, quantum fluctuations from the very first moments of the Big Bang had left some regions slightly denser than others. These tiny differences were imperceptible, mere ripples in the fabric of density, but over millions of years, they determined the fate of the cosmos. Gravity pulled at these denser regions. Slowly, inexorably, the gas began to clump together, atom by atom. The hydrogen clouds grew heavier. As they grew, their gravitational pull increased, drawing in even more gas from the surrounding space. It was a runaway process, a gathering of the clans of matter. In the silence of the Dark Ages, the great structures of the universe were being laid down. The filaments of the cosmic web were forming, vast rivers of dark matter and gas flowing through the void, pooling into the nodes where the first galaxies would eventually be born. This process took hundreds of millions of years. It is a span of time that our human minds struggle to comprehend. We panic if we have to wait 5 minutes for a coffee. Yet the universe waited 200 million years just to make the first star. This patience is written into the very laws of nature. Complexity cannot be rushed. Consciousness cannot be forced. It must emerge, layer by layer, from the slow cooling of the fire. I want you to consider the hydrogen atom for a moment. It is the simplest thing in the universe. One proton, one electron. It is the basic building block of everything we know. In those early days, that is all there was. Just hydrogen, with a sprinkling of helium. It seems impossible that a gas, odorless, colorless, and tasteless, could eventually turn into a human being, asking questions about its own origin. As the physicist Edward Harrison once said, given enough time, hydrogen starts to wonder where it came from. And that is exactly what happened. You are, in a very literal sense, 14-billion-year-old hydrogen that has learned to think. The journey from that simple gas to the complexity of your neural network is a journey of increasing organization. It is the universe fighting against the pull of entropy, creating pockets of order in a chaotic world. During the Dark Ages, the universe was simple. It was smooth. It was uniform. But consciousness requires complexity. It requires difference. It requires a separation between the self and the other. In the smooth soup of the early cosmos, there was no place for a mind to take hold. There was nothing to look at and no one to look. The universe had to break its own symmetry to create the conditions for life. It had to become clumpy. It had to become uneven. It had to create hot spots and cold spots, dense regions and empty voids. This breaking of perfection is what allowed for the possibility of us. It is a beautiful irony that our existence depends on the universe being imperfect. If the distribution of matter after the Big Bang had been perfectly smooth, gravity would have had no purchase. No stars would have formed. No planets would have coalesced. The universe would have remained a cold, dark, expanding mist forever. We are the children of imperfection. We are the result of a cosmic flaw. As the great clouds of hydrogen collapsed under their own weight, the pressure at their centers began to rise. The atoms, which had been drifting lazily through the cold dark, began to collide. They rubbed against each other, generating heat. The temperature, which had been near absolute zero, began to climb. 100 degrees, 1,000 degrees, 1,000,000 degrees. Deep inside these collapsing clouds, the conditions were returning to the inferno of the Big Bang. The universe was preparing to light its first lamps. It was preparing to end the Dark Ages. But before the first star could shine, the universe had to learn a new trick. It had to learn nuclear fusion. It had to learn how to squeeze atoms together so hard that they merged, releasing a tiny spark of energy in the process. This is not an easy thing to do. Protons are positively charged, and they hate to be close to each other. They repel each other with a fierce force. To overcome this repulsion, you need immense heat and immense pressure. You need the weight of 1,000,000 Earths pressing down on a single point. In the hearts of these first protostars, the battle between gravity and pressure was waged. Gravity wanted to crush the cloud into a singularity. The heat generated by the compression wanted to blow the cloud apart. For millions of years, these forces wrestled in the dark. And then, in a moment of cosmic inevitability, gravity won. The core temperature hit 10,000,000 degrees. The protons, moving at incredible speeds, could no longer avoid each other. They smashed together, fusing into helium, and in that act of fusion, a tiny amount of mass was converted into pure energy, according to Einstein's famous equation. A photon was born, and then another, and then a trillion more. The pressure of this escaping light pushed back against gravity, balancing the crushing weight of the star. The collapse stopped. The star stabilized. And for the first time in hundreds of millions of years, a point of light pierced the absolute darkness. The first stars were monsters. They were hundreds of times more massive than our sun, burning with a ferocious blue-white intensity. They were not gentle nurturers of life. They were violent, raging giants. They lived fast and died young, burning through their fuel in just a few million years. But their existence changed everything. They poured ultraviolet light into the surrounding gas, reionizing the universe, ending the Dark Ages, and sculpting the nebulas into strange and beautiful shapes. But more importantly, these first stars were factories. Inside their cores, they were doing something that had never been done before. They were taking the simple hydrogen and helium of the Big Bang and forging heavier elements. They were making carbon. They were making oxygen. They were making nitrogen. they were making the stuff of life. Think about that for a moment. The very atoms that now make up the hand holding your phone or the eyes reading these words did not exist in the beginning. The universe had to make them. It had to cook them in the bellies of giant stars. Before these first stars, there was no chemistry as we know it. There was no water, for there was no oxygen to bind with hydrogen. There was no rock, for there was no silicon. There was certainly no biology. The potential for consciousness was there, locked in the laws of physics, but the materials were missing. The universe had to build the Lego bricks before it could build the castle. It had to invent the alphabet before it could write the poetry. These first stars were the crucibles of complexity. They were the ovens in which the ingredients of you were baked. When we look back at this era, we see a universe that is waking up from a long slumber. It is shaking off the simplicity of its birth and beginning the hard work of creation. It is a time of violence, yes, of massive stars forming and exploding, but it is also a time of profound creativity. The universe is learning how to be more than just gas. It is learning how to be solid. It is learning how to be complex. It is a slow process unfolding over eons, but the direction is clear. The cosmos is moving from simplicity to complexity, from darkness to light, from unconscious matter to the possibility of mind. We often ask why we are here. Why does the universe exist? These are questions that science struggles to answer. But we can answer the question of how we are here. We are here because the universe cooled. We are here because gravity was patient. We are here because the first stars burned and died to give us the ashes of their bodies. We are the result of a chain of events that stretches back 13.8 billion years, an unbroken lineage of energy transforming into matter, matter transforming into stars, stars transforming into elements, and elements eventually transforming into us. As we stand at the end of this first chapter of our history, the universe is no longer dark. It is speckled with the light of the first distinct fires. The stage is set. The actors, the heavy elements, are being created. But we are still a long way from the first thought, the first feeling, the first moment of awareness. The universe is awake, but it is not yet aware. It is a blindingly bright, chaotic, beautiful machine, churning out the raw materials of reality. But something else is needed. Something needs to take these raw materials and organize them into something fragile, something delicate, something capable of feeling pain and joy. The silence of the void has been broken by the roar of the first supernovas. The pristine purity of the primordial gas has been polluted, wonderfully polluted, with the dust of dead stars. This dust, this cosmic soot, is more precious than gold. It is the dust of dreams. It is the dust that will one day stand up and look back at the stars that made it. But for now, it drifts. It waits. The universe is taking its time, playing the long game. It knows, in its blind, physical way, that the most interesting things are yet to come. The era of the first light has ended. The era of the first galaxies is about to begin. And somewhere in that swirling dance of gravity and light, the possibility of you is waiting to be born. Have you ever stood on a high hill overlooking a city at night, watching the grid of lights stretch out to the horizon? From that distance, the chaos of individual lives, the traffic, the noise, the hurry, blends into a singular, glowing organism. You see the structure, the arteries of roads, the clusters of neighborhoods, the bright heart of the downtown core. It looks intentional, doesn't it? It looks like a master plan laid out by a careful hand. But we know that cities grow organically. messy and sprawling, shaped by the needs of millions of separate people. Now, I want you to close your eyes and imagine a city not made of concrete and glass, but of light and gravity. A city that spans 100,000 light years across, inhabited not by people, but by hundreds of billions of stars. This is a galaxy. And just like our earthly cities, these cosmic metropolises did not appear overnight. They grew, they evolved. They were built stone by stone, star by star, over eons of violent grace. If the first stars were the lonely pioneers lighting fires in the wilderness, galaxies are the great civilizations that rose from their ashes. The story of how the universe went from a scattered mist of hydrogen to the majestic spiral of the Milky Way is the story of the greatest construction project in history. And, remarkably, the foreman of this project is something we cannot see, cannot touch, and cannot even fully understand. We call it dark matter. When we look at the beautiful images from the Hubble Space Telescope or the James Webb Space Telescope, we see the glowing gas and the brilliant stars. We see the visible matter, the stuff that interacts with light. But this visible matter is just the frosting on a cosmic cake. The cake itself, the substance that gives the universe its heft and its shape, is dark matter. It makes up about 85% of the matter in the universe. Without it, you would not be here. Without it, the stars would have drifted apart, lost in the expanding void, never gathering close enough to form the stable homes we call galaxies. Imagine the universe as a vast, three-dimensional spider web. This is not a metaphor. It is the actual large-scale structure of the cosmos. Astronomers call it the cosmic web. The strands of this web are made of dark matter stretching across billions of light years of emptiness. It is a skeleton of invisible gravity. In the early universe, ordinary matter, the gas that would become stars, flowed along these dark filaments like water flowing down a riverbed. It pooled in the massive intersections where the strands crossed, drawn by the immense gravitational pull of the dark matter knots. It was here, in these deep gravitational wells, that the first galaxies began to form. They were not the elegant spinning pinwheels we see in textbooks today. They were messy, irregular blobs of gas and light crashing into each other, merging and growing larger in a chaotic frenzy of construction. This era, known as the Epoch of Orionization and subsequent galaxy formation, was a time of unimaginable turbulence. If you could have watched it unfold in time-lapse, you would have seen clouds of gas millions of times the mass of our sun slamming together. You would have seen shock waves rippling through the cosmos, triggering bursts of star formation that lit up the dark like fireworks. It was a violent, messy adolescence for the universe. But in the silence of space, this violence was a creative force. Gravity was ruthless. It did not allow matter to remain evenly spread. It demanded concentration. It demanded structure. It pulled the gas in tighter and tighter until the angular momentum took over. You know how a figure skater spins faster when she pulls her arms in? The same law of physics applies to galaxies. As the vast clouds of gas collapsed toward the center of these dark matter halos, they began to spin. They flattened out into disks, preserving their momentum, and the spiral structure was born. But there is a mystery at the heart of this process, a heavy silence that sits at the center of almost every large galaxy, including our own. It is the supermassive black hole. For a long time, astronomers thought these monsters were just accidental byproducts of galaxy formation, hungry mouths that eventually formed where the matter was densest. But we now believe that the black hole and the galaxy grow together, a symbiotic relationship between the creator and the destroyer. The black hole anchors the galaxy. its gravity influencing the motion of stars deep in the core, but it also regulates the galaxy's life. When a galaxy tries to form stars too quickly, when it gobbles up gas too greedily, the black hole wakes up. It feeds on the infalling material and blasts out jets of energy, radiation winds that blow the excess gas away, stopping the star formation. It is a cosmic thermostat, a breathing mechanism that prevents the galaxy from burning itself out too young. It ensures that the star formation is paced, slow and steady, allowing the galaxy to live for billions of years, long enough for life to evolve on a quiet planet, circling a quiet star. Think about the scale of this for a moment. We live on a planet that is 12,700 kilometers wide. Our sun is 1.4 million kilometers wide. The Milky Way galaxy is roughly 100,000 light-years wide. 1 light-year is about 9.46 trillion kilometers. To cross our galaxy at the speed of light would take 100,000 years. To cross it in a jet plane would take over 100 billion years. These numbers are not just statistics. They are a measure of our isolation. We are an island universe. Before the 20th century, we didn't even know other galaxies existed. We thought the Milky Way was the entire universe. It was only when Edwin Hubble looked through his telescope and saw that the nebulae were actually distant island universes that we realized how vast the cosmos truly is. There are estimated to be 2 trillion galaxies in the observable universe. 2 trillion. If you held a grain of sand for every galaxy, you would need a beach stretching for miles, and each one of those grains is a city of stars, a vessel of potential worlds, separated from us by an ocean of dark energy and expanding space that we will likely never cross. Yet, despite this vast separation, we are connected. We are connected by light. The photons that hit the sensors of our telescopes have traveled for millions, sometimes billions of years, carrying the history of those distant places. When we look at the Andromeda Galaxy, our nearest large neighbor, we are seeing it as it was 2.5 million years ago. We are looking back to a time when humans did not yet walk the earth. We are seeing ghost light, an image of the past. This delay is a gift. It allows us to be archaeologists of time. By looking at galaxies at different distances, we are looking at the universe at different ages. We can see the baby galaxies, small and blue, and bursting with new stars. We can see the teenage galaxies crashing into each other and changing shape. And we can see the old, red, elliptical galaxies, where star formation has ceased and the ancient stars drift in a quiet slumber. We can trace our own ancestry in these images. We can see where we came from. Let's return to the dust. Remember the soot from the first stars I mentioned? As galaxies formed and evolved, this dust became crucial. In the early universe, stars were made almost entirely of hydrogen and helium. But as generations of stars lived and died within the gravitational embrace of the galaxies, they enriched the interstellar medium. They pumped carbon, oxygen, silicon, and iron into the clouds. The galaxies became chemical mixing bowls. The spiral arms of the Milky Way are not just pretty structures. They are density waves, traffic jams in the gas where this material is compressed and mixed. As the galaxy rotates, these arms sweep through the gas, triggering new waves of star formation. It is a recycling system on a galactic scale. The galaxy is a living ecosystem, breathing in gas, turning it into stars, and exhaling enriched dust back into the void. This enrichment is what allowed the universe to change its color. The early universe was blue and white, the colors of hot, massive, primitive stars. But as the heavy elements accumulated, they allowed for the formation of cooler, smaller, redder stars. They allowed for the formation of dust lanes that absorb light and re-radiate it as infrared heat. The universe became multicolored. It became texturally complex. And, most importantly for us, this heavy dust allowed for the formation of solid objects. You cannot build a rocky planet out of hydrogen gas. You need iron. You need magnesium. You need silicates. You need the ashes of the galactic furnace. It took billions of years of galactic evolution to build up enough heavy elements to make a solar system like ours possible. We are latecomers to the party, and that is a good thing. If we had arrived earlier, the universe would have been too poor in metals to build the Earth. We needed the galaxies to do their work first. We needed the cosmic ovens to bake the clay of existence. There is a profound beauty in the way gravity imposes order on chaos. Without gravity, the universe would be a thin, cold soup. With gravity, we get structure, we get hierarchy. Moons orbit planets, planets orbit stars, stars orbit the centers of galaxies, and galaxies orbit each other in clusters. It is a dance of circles within circles, a celestial clockwork that ticks on timescales of billions of years. But it is not a rigid clockwork. It is dynamic. Galaxies collide. The Milky Way is currently eating several smaller dwarf galaxies. In about 4 billion years, we will collide with Andromeda. It will not be a crash of solid objects, for galaxies are mostly empty space. It will be a ghostly merger, a passing of stars through the gaps between stars. The two spirals will distort, stretch, and eventually combine into a single, massive, elliptical galaxy. Our night sky, if anyone is there to see it, will change completely. The band of the Milky Way will be replaced by a haze of 1 trillion stars. It is a reminder that nothing in the universe is static. Even the largest structures are in motion, flowing through the river of time. This constant motion, this evolution, raises a deep question. Is the universe conscious of itself? We tend to think of consciousness as something that happens inside a brain. But if the laws of physics drive matter to organize into ever more complex structures, from atoms to stars to galaxies, is it possible that the universe is driving toward consciousness? Is the emergence of mind a fluke, an accident of chemistry? Or is it an inevitable consequence of a universe that creates complexity? Some physicists and philosophers have suggested that the universe is a kind of information processing system. It computes its own future, and perhaps we are the localized nodes of that computation. We are the way the universe feels its own existence. When you look at a galaxy, you are not just seeing a collection of stars. You are seeing the womb that birthed the conditions for your own mind. You are looking at your ancestral home, writ large in the sky. The environment within a galaxy is not uniform. There are dangerous places and safe places. The core of the galaxy is crowded, chaotic, and bathed in intense radiation from the central black hole and dense clusters of stars. It is not a good place for delicate life to evolve. The outer edges are too sparse, lacking the heavy elements needed to build planets. We live in the Goldilocks zone of the Milky Way, the galactic habitable zone. We are about 26,000 light-years from the center, in a quiet spur of the Orion Arm. We are far enough from the dangerous core to be safe, but close enough to the star-forming regions to have the materials we need. We are in the cosmic suburbs. It is quiet here. The stars are spread out just enough to give us a dark night sky, but close enough to inspire our wonder. It is a privileged position, a front-row seat to the majesty of the cosmos, without being in the middle of the mosh pit. As we journey through this galactic era, the universe is about 9 billion years old. The frantic activity of the early days has slowed down. The peak of star formation has passed. The universe is settling into middle age. It is a mature cosmos, filled with stable, majestic galaxies turning slowly in the dark. The expansion of the universe is carrying these galaxies apart from each other, stretching the cosmic web. The distances are growing, the silence is deepening, but within the protective gravitational embrace of the Milky Way, something special is about to happen. In a nondescript cloud of gas and dust, enriched by the deaths of 1,000 previous stars, a shock wave from a distant supernova is passing through. It is a gentle nudge, just enough to disturb the equilibrium. Gravity takes hold again. The cloud begins to collapse. It begins to spin. This is the moment we have been waiting for. We have seen the universe born in fire. We have seen the first stars light up the dark. We have seen the great galaxies spin into existence. Now, the camera zooms in. We leave the vast scale of the intergalactic void and focus on a tiny corner of the Milky Way. We focus on a swirling disk of dusty material that is about to become the most important place in the universe for us. We are about to witness the birth of the sun. We are about to witness the creation of the stage where the final act of consciousness will be played out. The wandering hydrogen atoms, having traveled for billions of years, having been part of other stars and other worlds, are gathering for one final performance. They are coming home. The journey is far from over. In fact, the most intimate part is just beginning. We have built the house. Now we must furnish the room. We must forge the planets. We must create the oceans. We must spark the first replicating molecule. But as you drift off to sleep tonight, think of the galaxy that holds you. Think of the invisible dark matter that cradles our star system like a mother holding a child. Think of the black hole that breathes in the center, regulating the pulse of creation. You are safe here in this island of light, floating in the infinite dark. The universe has worked very hard for very long to build this sanctuary for you. Rest in that knowledge. Rest in the gentle gravity that holds you to your bed, the same force that holds the galaxy together. The stars are watching. The cosmos is breathing. And tomorrow we will watch a solar system form from the dust of dreams. Have you ever looked at the gold ring on a finger or the iron in the red soil of a garden and wondered where it truly came from? We are taught in school that the earth is rich in minerals, that we mine them from the ground. But the earth did not make these things. The earth cannot make gold. It cannot make iron. It cannot even make the carbon that forms the backbone of your DNA. To find the true forge of these elements, you have to look up. You have to look back in time to the death of stars that lived and died long before our sun was born. We are standing on a graveyard of celestial giants, and our bodies are built from their ashes. The story of our solar system does not begin with the sun. It begins with a death. It begins with a supernova, a detonation so powerful that for a few weeks, a single star outshines its entire galaxy. Imagine a star 20 times the mass of our sun, aging gracefully in a spiral arm of the Milky Way 5 billion years ago. For millions of years, it has balanced the crushing force of gravity with the explosive power of nuclear fusion. It has burned hydrogen into helium, helium into carbon, carbon into oxygen, neon, silicon, and finally iron. But iron is the star killer. Fusing iron consumes energy rather than creating it. The fire goes out. In a fraction of a second, gravity wins the war it has been waging for eons. The core collapses. The outer layers crash inward at a quarter of the speed of light, hit the impossibly dense core, and bounce back. The star explodes. In that moment of violent destruction, The universe does something magical. The shock wave is so intense, the temperature's so high, that atoms are smashed together to form the heaviest elements on the periodic table. Gold, platinum, uranium, all forged in the fires of a dying star. This debris is blasted out into the cosmos, mixing with the hydrogen gas of the interstellar medium. This is the stardust we are made of. This is the star stuff that Carl Sagan famously spoke about. Now, drift with me into a vast, cold molecular cloud floating about 26,000 light-years from the galactic center. It is a quiet place, dark and cold, filled with gas and the microscopic dust grains enriched by those ancient explosions. For millions of years, this cloud hangs in equilibrium. But then, a ripple passes through it. Maybe it was the shock wave from a nearby supernova, or the density wave of a spiral arm passing by. Whatever the trigger, gravity wakes up. A pocket of gas begins to collapse. It draws in material from its surroundings, spinning faster and faster as it shrinks. This is the solar nebula, the womb of our solar system. In the center, the pressure builds, the temperature rises. The protostar that will become our sun begins to glow, a dull red ember in the dusty dark. Around this infant sun, a disk of leftover material swirls. This is the protoplanetary disk. It is a chaotic, violent place. Dust grains collide and stick together, held by static electricity. They grow from microscopic specks to pebbles, from pebbles to boulders, from boulders to mountains. These are planetesimals, the seeds of worlds. They smash into each other, merging and breaking, a cosmic demolition derby played out over millions of years. In the hotter inner region near the young sun, the volatile gases are boiled away. Only rock and metal can survive. Here, the terrestrial planets form: Mercury, Venus, Earth, Mars. In the colder outer regions, beyond the frost line, ices can survive. Huge cores of rock and ice gather massive atmospheres of hydrogen and helium. Here, the gas giants are born: Jupiter, Saturn, Uranus, Neptune. Let's focus on the third rock from the sun. The early Earth was not the blue marble we know today. It was a hellscape. Astronomers call this the Hadean Aeon, named after Hades, the Greek underworld. The planet was molten, a ball of magma roiling in the dark. There was no solid ground, only a shifting skin of cooling lava that would crack and sink back into the melt. The sky was not blue, but red and orange, choked with volcanic gases. Meteors rained down constantly, scarring the surface, keeping the planet hot. It is hard to believe that this inferno would one day host forests and oceans and cities. But chaos is often the precursor to order. The heat was necessary. It allowed the heavy iron and nickel to sink to the center, forming the core. This core is crucial. It generates the magnetic field that protects us from the solar wind. Without this molten heart, our atmosphere would have been stripped away long ago, and Earth would be as dead as Mars. Then, about 4.5 billion years ago, a catastrophe occurred that defined our planet's future. A planet the size of Mars, which we call Theia, was on a collision course with Earth. It smashed into our young world with a force that defies comprehension. The impact was so violent that it liquefied the Earth's surface again. It blasted a huge amount of debris into orbit. For a short time, Earth had a ring system like Saturn, but made of molten rock. Over just a few thousand years, a blink of an eye in cosmic time, this debris coalesced under its own gravity. It formed a second sphere, scarred and gray, forever locked in a dance with its parent. The moon was born. This collision was a stroke of incredible luck. The moon acts as a stabilizer for Earth. Its gravity keeps our planet's tilt steady. Without the moon, Earth might wobble wildly on its axis, causing chaotic climate swings that could make the evolution of complex life impossible. The moon also gives us tides, the gentle rising and falling of the oceans, the mixing of nutrients in the coastal zones may have been essential for the first life to move from the sea to the land. When you look up at the full moon, you are looking at the scar of a cosmic accident that made your existence possible. You are looking at a piece of the earth that was flung into the sky, a silent guardian that has watched over every moment of history. As the bombardment of meteors slowed, the earth began to cool. The magma skin hardened into a crust of black basalt. Volcanoes continued to erupt, belching steam and carbon dioxide into the atmosphere. And then something miraculous happened. The steam condensed. The first drop of rain fell. It hissed as it hit the hot rock, evaporating instantly. But more drops followed. The atmosphere was thick with water vapor, and as the planet cooled further, the heavens opened. It rained. It rained for thousands, perhaps millions of years. It was a deluge of biblical proportions, a storm that drowned the world. The basins filled. The lowlands became seas. The global ocean was born. Imagine standing on the shore of that primordial ocean 4 billion years ago. The water is green with dissolved iron. The sky is orange with carbon dioxide. The sun is fainter than it is today, a pale yellow disk in the haze. The moon is much closer, looming huge in the sky, raising tides thousands of feet high that scour the barren continents. It is an alien world, hostile and toxic. Yet, in the depths of those green oceans, near the hydrothermal vents spewing mineral-rich water from the interior, chemistry is about to become biology. The atoms are restless. They are bonding, breaking, and bonding again. Carbon, hydrogen, oxygen, nitrogen, phosphorus, sulfur, the 6 elements of life, are dancing in the dark. This transition from non-living matter to living matter is the deepest mystery in science. We call it abiogenesis. We do not know exactly how it happened. We do not know if it started in a warm little pond on the surface, or in the high-pressure darkness of a deep-sea vent, or even if the seeds of life were delivered by comets. But we know that it happened. Somehow a molecule formed that could copy itself. It was likely a primitive form of RNA, a fragile chain of atoms that carried information. This was the spark. This was the moment the universe began to write a code. Before this, information existed only in the laws of physics. Now, information existed in the arrangement of atoms. The code could change. It could evolve. It could learn. The first life was microscopic, simple, and fragile. It was a single cell, a tiny bubble of fatty acids protecting a delicate strand of genetic material. It lived in a world without oxygen. It fed on the chemical energy of the earth itself. For billions of years, these single-celled organisms were the only inhabitants of the planet. They drifted in the currents, divided, and died. It seems like a boring era, a long stagnation. But evolution is never idle. Inside those cells, molecular machinery of incredible complexity was being refined. They were learning how to harvest energy from the sun. They were inventing photosynthesis. This invention changed the world more than any other event in history. A type of bacteria called cyanobacteria figured out how to use sunlight to split water molecules. They took the hydrogen for themselves and released the oxygen as waste. This waste product was deadly to most life on Earth at the time. It was a poison, but it accumulated in the atmosphere, slowly turning the orange sky blue. It rusted the iron out of the oceans, creating the vast deposits of red iron ore that we mine today. This was the Great Oxidation Event. It was a mass extinction for the anaerobic life that ruled the world, but it paved the way for us. Oxygen is a high-energy fuel. It allows for active, fast-moving metabolism. It allows for brains. It allows for consciousness. While life was taking hold, the earth itself was moving. The crust is not a solid shell. It is broken into tectonic plates that float on the semi-molten mantle below. Driven by the heat of the core, these plates drift, collide, and separate. Continents have assembled into supercontinents and broken apart again in a cycle that lasts hundreds of millions of years. Mountains have risen and been worn down to nubs. Oceans have opened and closed. The geography of Earth is fleeting. If you could time travel, you would not recognize the map. This geological activity is vital. It recycles carbon. It regulates the temperature. It creates diverse environments, mountains, valleys, shallow seas, deep trenches, that force life to adapt and evolve. We are creatures of the land, but our ancestors were creatures of the sea, shaped by the shifting tides and the drifting continents. Let's pause and consider the improbability of this planet. We are at just the right distance from the sun for water to be liquid. If we were a little closer, like Venus, our oceans would have boiled away. If we were a little farther, like Mars, they would have frozen. We have a large moon to stabilize us. We have a magnetic field to shield us. We have a large neighbor, Jupiter, whose immense gravity acts as a vacuum cleaner, sucking up asteroids and comets that might otherwise hit us. We have plate tectonics to keep the chemistry of the atmosphere in balance. It is a long list of lucky breaks. Some scientists call this the rare earth hypothesis, the idea that simple life might be common, but complex intelligent life is exceedingly rare because it requires such a specific sequence of fortunate events. Whether we are rare or common, we are undeniably made of this world. The water in your cells is the same water that rained down in the Hadean deluge. The salt in your blood is a memory of the primordial ocean. The calcium in your bones was dissolved from ancient rocks. We are not passengers on spaceship Earth. We are the crew. We are the ship itself, waking up. We are the way the Earth knows itself. When you walk in a forest, you are not walking on the Earth. You are the Earth walking. You are a mobile piece of the biosphere, a sensory organ of the planet. This connection goes deeper than biology. It goes to the very physics of our existence. The atoms in your body are mostly empty space. If you removed the empty space from all the people on Earth, the entire human race would fit into the volume of a sugar cube. What gives you solidity? What makes you feel like you are here is the electromagnetic force. It is the fields of energy interacting. You are a pattern of energy, a standing wave in the quantum field. You are a process, not a static object. You are a river of matter, constantly flowing. The cells in your body are dying and being replaced every second. The atoms you are made of today are not the same atoms you were made of a year ago. You are a flame, burning through the fuel of the world, maintaining your shape even as your substance changes. As the solar system settled into its current configuration, the stage was set for the next great leap. The planet was blue, wet, and teeming with microbial life. The continents were barren rock, but the seas were alive. The sun, once a dim, moody teenager, had settled into a steady, middle-aged burn, providing a constant source of energy. The moon continued its silent watch, slowly drifting away from the Earth by a few centimeters a year, slowing our rotation, lengthening our days. The violence of the beginning was over. The long, slow work of evolution was underway. It is easy to feel small when we talk about these timescales. 4.5 billion years. What is a human life against such an abyss of time? It is a spark in the dark. But remember, the universe does not measure value in duration. A single thought, a single moment of love, a single realization of beauty has a quality that a billion years of burning hydrogen lacks. Consciousness is the rarest thing we know of. It is the universe's way of turning the lights on. Without minds to perceive it, the universe is just a machine running in the dark. With minds, it becomes a story. It becomes a tragedy, a comedy, a romance. It becomes meaningful. We are now standing at the threshold of complexity. The single cells are about to learn how to cooperate. They are about to join forces to create multicellular organisms. They are about to invent eyes and hearts and nervous systems. They are about to crawl out of the water and conquer the land. The journey from the first replicating molecule to the human brain is a long and winding road full of dead ends and mass extinctions. But life is resilient. Life is stubborn. Once the flame is lit, it is very hard to blow out. The earth has frozen over completely, turning into a snowball. It has been hit by asteroids that wiped out 90% of all species. It has been choked by volcanic ash, and yet life bounced back every time, more complex, more diverse than before. So, tonight, as you lay your head on the pillow, feel the weight of your body. That is gravity, the same force that pulled the solar nebula together. Listen to your breath. That is the exchange of oxygen produced by ancient bacteria. Feel the warmth of your skin. That is the energy of the sun, captured by plants and transferred to you. You are a child of the solar system. You are the result of stars exploding, of dust collapsing, of planets colliding. You are the universe's masterpiece, 4 billion years in the making. And the story is just getting interesting. The silent rocks are about to speak. The blind waters are about to see. The sleeping planet is about to dream. Have you ever watched a single drop of water under a microscope? It is a chaotic, bustling world. Tiny, translucent shapes dart back and forth, spinning, eating, dividing. It is a frenzy of activity. Now, imagine expanding that drop of water to cover the entire globe. For nearly 3 billion years, this was the reality of Earth. It was a planet of microbes, a slime world. From space, it would have looked quiet, perhaps a little green in the oceans, but the continents were bare, gray rock. There were no trees to rustle in the wind, no birds to sing, no animals to leave footprints in the sand. It was a time of immense, grinding slowness. Scientists sometimes call a large part of this era the boring billion. It seems as if evolution had stalled, as if the creative spark of the universe had flickered out. But silence can be deceiving. Deep in the invisible machinery of the cell, a revolution was brewing. The universe was not sleeping. It was engineering the most complex machine it had ever built, the eukaryotic cell. We often take our bodies for granted. We think of ourselves as single individuals. But you are not one thing. You are a colony. You are a walking city of 30 trillion cells, each one a marvel of biological architecture. And every single one of those cells is a descendant of a singular, unlikely event that happened in those quiet oceans 2 billion years ago. It began with a meal that went wrong. One simple predatory bacterium engulfed another, smaller bacterium. Usually the story ends there. The predator digests the prey. But this time, something miraculous happened. The smaller bacterium did not die. It survived. It struck a deal with its captor. It said, "I will provide you with extra energy if you provide me with shelter and food." They became partners. Over millions of years, they became one. That trapped bacterium became the mitochondrion, the power plant that exists in every cell of your body today. This merger, known as endosymbiosis, was the spark that ignited the fuse of complexity. Before this, life was limited by energy. Simple bacteria can only generate so much power. They hit a ceiling. But with mitochondria, cells suddenly had a turbocharger. They had thousands of times more energy at their disposal. They could afford to get bigger. They could afford to carry more DNA. They could afford to experiment. This was the moment the universe moved from the age of the simple to the age of the complex. It was the moment biology invented the heavy machinery needed to build a thinking mind. When you take a deep breath, you are feeding these ancient guests inside your cells. You are keeping a 2-billion-year-old pact alive. You are the result of an ancient act of cooperation, a biological marriage that changed the destiny of the planet. With this new energy, life began to experiment with a radical new idea: community. For eons, every cell was an island, fighting for its own survival. But now, some cells discovered that they were stronger together. They began to clump. They began to specialize. One cell would say, "I will handle the digestion," and another would say, "I will handle the movement," and a third would say, "I will be the shield." They gave up their individuality for the good of the whole. This is the birth of multicellularity. It is a profound philosophical shift. The self expanded. It was no longer just me. It was us. It was the first step toward the complex societies of cells that make up a human brain. It was the universe learning that the whole is truly greater than the sum of its parts. Then, about 540 million years ago, the curtain rose on the most dramatic act in the history of life, the Cambrian explosion. In a geological blink of an eye, just a few distinct layers of rock, the oceans were suddenly filled with monsters. Evolution went into overdrive. It was as if a biological bomb had gone off. All the major body plans of animals appeared at once. We find their fossils in the Burgess Shale in Canada, creatures so strange they look like hallucinations. There was Opabinia, with 5 eyes and a nozzle-like proboscis. There was Hallucigenia, a spiky worm that walked on stilts. There was Anomalocaris, the first super-predator, a meter-long terror with crushing plates for a mouth. Why did this happen? Why the sudden riot of forms? Many scientists believe it was sparked by the invention of a single, devastatingly powerful tool: the eye. Before the Cambrian, the world was experienced through touch and smell. It was a tactile, chemical world. Predators bumped into their prey in the dark. But then, evolution stumbled upon a way to focus light. The first eyes were simple spots, barely able to tell night from day. But soon, they sharpened, they gained lenses, they gained focus, and suddenly, the universe could see itself. The invention of vision changed the rules of the game forever. If a predator can see you, you cannot just drift aimlessly. You need armor. You need camouflage. You need speed. You need to burrow. The arms race began. This arms race drove the development of complexity. The pressure to survive, the fear of being eaten, forced life to become smarter, faster, and harder. It forced the development of skeletons, hard shells of calcium carbonate that could protect soft bodies. These shells are what allowed us to have a fossil record. Before this, life was soft and squishy and rotted away without a trace. But now, life was leaving a monument in stone. It was writing its history in the bedrock. The drama of life, the hunter and the hunted, the chase, the escape, had begun in earnest. And in the midst of this violence, a small, unassuming creature appeared. It looked like a worm, but it had a stiff rod of cartilage running down its back. It was Bikaya. It was our ancestor. That stiff rod was the precursor to the backbone. We are the children of that worm. We are the vertebrates, the lineage that would one day conquer the land and the sky. But the land was still silent. For billions of years, while the oceans teemed with monsters, the continents were barren. They were deserts of rock and sand, scoured by wind and radiation. The sun blasted the surface with ultraviolet light, untamed by an ozone layer. But life is an expansionist force. It abhors a vacuum. It pushes against every boundary. Around 470 million years ago, the first pioneers made the journey. They were not animals. They were plants, simple mosses and liverworts, creeping out of the water, clinging to the wet rocks near the shore. They were the terraformers. They slowly broke down the rock, creating the first soil. They pumped oxygen into the air, thickening the shield against the sun. They turned the gray world green. Imagine the silence of those first forests. There were no leaves rustling, for there were no broad-leafed trees yet. There were no buzzing insects. There were no bird calls, just the sound of wind over moss and the endless crash of the waves. It was a green silence, a waiting world. But soon the animals followed. The first were the arthropods, the ancestors of insects, spiders, and scorpions. They were pre-adapted to the dry world with their hard exoskeletons, which kept their moisture inside. They scurried through the primitive moss forests, the first creatures to walk on dry land. They were the rulers of this new world for millions of years. And then came the fish, not normal fish, but strange, lobe-finned fish that lived in the shallow, muddy swamps at the edge of the world. One of them, a creature we call Tiktaalik, had a peculiar feature. Its fins had bones inside them, a humerus, a radius, an ulna, the same bones that are in your arm right now. It could do a push-up. It could drag itself out of the oxygen-poor water and gulp air into a primitive lung. It was a reluctant explorer, probably just looking for a new pool of water or escaping a predator. But that stumble onto the mud was the most significant step in vertebrate history. It was the moment we left the cradle. It was the moment the path to humanity opened up. Those four limbs would eventually become the legs of dinosaurs, the wings of eagles, the flippers of whales, and the hands that built the pyramids. Time marched on. The plants grew taller. They invented a new molecule called lignin, a tough fibrous material that allowed them to stand up against gravity. They became trees. Vast forests of club mosses and giant ferns spread across the continents. This was the Carboniferous period, about 300 million years ago. The air was thick and humid. The oxygen levels soared to 35%, much higher than today. This oxygen-rich atmosphere allowed for giants. Dragonflies with wingspans of 2 feet hummed through the air. Millipedes the size of crocodiles crawled on the forest floor. It was a world of titans. But there was a flaw in this paradise. The bacteria and fungi of the time had not yet figured out how to digest lignin. When these giant trees died, they did not rot. They fell into the swamps and just sat there, piling up layer upon layer for millions of years. The carbon they had pulled from the atmosphere was locked away, buried in the mud. Over eons, heat and pressure turned this buried forest into black rock. We call it coal. The energy that powers our modern world, the electricity that lights your home, is the sunlight captured by those carboniferous trees 300 million years ago. We are burning the ghosts of an ancient forest. We are releasing the breath of a forgotten world. This burial of carbon had a side effect. It pulled so much carbon dioxide out of the atmosphere that the planet plunged into an ice age. The global temperature dropped. The great forests collapsed. The world became drier, harsher. The lush swamps were replaced by deserts. And in this crucible of climate change, a new type of egg evolved, the amniotic egg. It had a hard shell that kept the water inside. It was a private pond that the animal could take with it. This meant that reptiles, the descendants of those first amphibians, were no longer tied to the water. They could venture inland. They could conquer the deserts. They could go where no vertebrate had gone before. The age of amphibians ended. The age of reptiles began. But life is never safe. The universe is indifferent to its creations. About 252 million years ago, the Earth suffered its greatest tragedy. It is known as the Great Dying, the Permian-Triassic extinction event. In Siberia, the ground opened up. Massive volcanoes, the Siberian traps, erupted not for years, not for centuries, but for hundreds of thousands of years. They spewed millions of cubic kilometers of lava, covering a region the size of Europe. But the lava was not the killer. The gas was. The volcanoes released trillions of tons of carbon dioxide and methane. The planet fevered. The oceans warmed and lost their oxygen, turning into stagnant, purple pools of poisonous bacteria. Hydrogen sulfide gas, smelling of rotten eggs, bubbled out of the sea and poisoned the air. It was the closest life ever came to being extinguished completely. 95% of all species on Earth vanished. The trilobites, which had ruled the oceans for 300 million years, were wiped out. The giant insects, the ancient forests, the strange reptiles, gone. The slate was wiped almost clean. Imagine walking on that Permian Earth. It is a wasteland. The silence is absolute. The wind howls over a landscape of dead stumps and gray ash. The oceans are still and lifeless. It looks like the end of the story. It looks like the experiment of consciousness has failed. But life is stubborn. Life is a flame that hides in the embers. Deep in burrows, under rocks, in the few remaining cool spots, a handful of survivors clung to existence. Among them were small, unassuming, lizard-like creatures called synapsids. They were hairy. They were warm-blooded. They were the ancestors of mammals. They were our great-grandparents, shivering in the dark, waiting for the volcanoes to stop, and eventually the eruptions ceased. The carbon dioxide was slowly scrubbed from the air by the weathering of rocks. The oceans cooled and reoxygenated. The recovery took 10 million years, a long, painful scar in the geological record. But the biosphere healed. This resilience is perhaps the most profound lesson of biology. The universe tries to kill life again and again. It throws asteroids. It erupts volcanoes. It freezes the planet. It irradiates the surface. And yet, life adapts. It shifts. It finds a new way. The extinction did not stop the flow of consciousness. It redirected it. The Great Dying cleared the stage for the next act. It removed the old guard and created a vacuum that would be filled by the most famous creatures of all, the dinosaurs. But it also forced our ancestors into the shadows, into the night, where they would sharpen their senses and develop bigger brains just to survive. Think about the fragility of your own existence. If that asteroid had missed, if those volcanoes had not erupted, if that one fish had not crawled onto the land, you would not be here. The chain of events that leads to you is a thread suspended over an abyss. It is a miracle of probability. We are the survivors of survivors of survivors. We carry the trauma and the triumph of the past in our very biology. The structure of your spine is a legacy of the first fish. The way your embryo develops mimics the history of your evolution. You are a museum of life, a walking record of 4 billion years of struggle. As we move toward the age of giants, the Mesozoic, the world is changing again. The supercontinent Pangaea is beginning to break apart. The Atlantic Ocean is unzipping. The climate is warming. The survivors of the Great Dying are radiating out, evolving into new and terrifying forms. The first true dinosaurs are appearing, small and agile, running on 2 legs. The first true mammals are scurrying underfoot, tiny and shrew-like. The lines are drawn. The day belongs to the reptiles. The night belongs to us. This separation of day and night is crucial for the development of the mind. In the safety of the dark, mammals had to rely on hearing and smell. They had to process complex auditory landscapes. This required a different kind of brain architecture, the neocortex. The seed of the human intellect was planted in the dark of the Mesozoic night, hidden from the eyes of the ruling dragons. While the dinosaurs grew massive, relying on brute strength and size, the mammals grew clever. We played the long game. We invested in processing power. We invested in social bonds. We invested in the care of our young. The journey of consciousness is not a straight line. It is a branching tree, pruned by catastrophe. It is a story of creative destruction. The universe breaks things to make better things. It destroyed the first generation of stars to create the elements for planets. It destroyed the anaerobic world to create the oxygen atmosphere. It destroyed the Permian world to make way for the dinosaurs. And, as we will see, it will destroy the dinosaurs to make way for us. There is a ruthlessness to this progress, but also a majesty. It suggests that consciousness is not an easy prize. It is hard won. It is forged in fire and ice. So, when you look in the mirror, do not just see a face. See the culmination of an epic. See the eukaryotic merger in your eyes. See the Cambrian explosion in your skeleton. See the conquest of land in your lungs. See the survival of the great dying in your warm blood. You are an ancient thing wearing a modern face. You are the universe's memory, waking up to tell its own story. The dust has become flesh. The water has become blood. The energy has become thought. And we are still only halfway through the story. The giants are coming. The asteroid is coming. The ice is coming. And the mind is just beginning to open its eyes. Have you ever stood beneath the skeleton of a Tyrannosaurus Rex in a museum and felt a primal shiver of fear? That fear is not learned. It is remembered. It is a genetic echo, a ghost frequency broadcast from the deepest, oldest parts of your brain. For 160 million years, our ancestors lived in a world of monsters. They were not the masters of their domain. They were the snacks. We often think of the age of dinosaurs as a time of primitive failure, a prelude to the real history of mammals. But this is human arrogance speaking. The dinosaurs were one of the most successful experiments the universe ever ran. They conquered every continent. They grew to sizes that defy biomechanics, becoming the largest land animals to ever walk the earth. They were warm-blooded, active, social, and likely colorful. They were the undisputed kings of the Mesozoic, and in their shadow, scurrying through the underbrush, living in burrows, coming out only at night, was a tiny, shrew-like creature. It was insignificant. It was weak, but it possessed a secret weapon that would eventually allow its descendants to build spaceships. It had a brain built for the dark. The dominance of the dinosaurs forced our ancestors into a nocturnal existence. This is known as the nocturnal bottleneck. It sounds like a prison sentence, but it was actually a forge. In the bright light of day, vision is the primary sense. But in the dark, you need more. You need to hear the snap of a twig 100 meters away. You need to smell the pheromones of a mate or the breath of a predator on the wind. To process this complex auditory and olfactory information, the mammalian brain had to change. It had to develop new layers of neural tissue. The neocortex, the wrinkled outer layer of the brain where conscious thought, language, and planning reside, began to expand during this long, dark exile. We literally thought our way through the night. While the dinosaurs relied on size and brute force, we relied on processing power. We became the hackers of the biological world, rewriting the software of survival while the hardware giants slept. But the universe is not static. While the biological drama played out on the surface, the planet itself was restless. The supercontinent Pangaea had broken apart, and the continents were drifting toward their modern positions. This separation created isolation, allowing different lineages of dinosaurs and mammals to evolve in unique ways on different land masses. And then there was the flowers. For most of Earth's history, the world was green and brown. Ferns, conifers, and cycads dominated. But in the Cretaceous period, about 130 million years ago, a revolution of color occurred. Angiosperms, flowering plants, appeared. They invited insects to carry their pollen, creating a symbiotic relationship that exploded into diversity. The world was suddenly painted in reds, yellows, and purples. With flowers came fruit, and fruit is a concentrated packet of solar energy, a sugar bomb that would eventually fuel the high metabolism brains of primates. The invention of the flower was the invention of the high-octane fuel that consciousness would eventually run on. And then, on a spring day 66 million years ago, the luck of the dinosaurs ran out. It was a day like any other. The sun rose over a lush tropical world. Hadrosaurs grazed in the fern prairies. Pterosaurs wheeled in the sky. But high above, silent and invisible, a rock the size of Mount Everest was hurtling through the vacuum of space at 40,000 miles per hour. It was an asteroid, a remnant of the early solar system, a piece of cosmic debris that had been nudged out of its orbit millions of years prior. It crossed the orbit of Earth at the precise moment our planet was there. If it had arrived 20 minutes earlier or 20 minutes later, it would have missed. The dinosaurs would have continued to rule. You and I would not exist. We are the accidental beneficiaries of a cosmic traffic accident. The impact site was the Yucatan Peninsula in modern-day Mexico. When the asteroid hit, it didn't just crash, it vaporized. The energy released was equivalent to billions of atomic bombs detonating at once. It punched a hole in the atmosphere, creating a vacuum that sucked debris back into space. A pillar of superheated plasma rose all the way to the moon. The bedrock was liquefied. A ring of mountains, the Peak Ring, rose and collapsed in minutes. The shock wave flattened forests for thousands of miles. Tsunamis the height of skyscrapers raced across the oceans, scouring the coastlines of entire continents. But the immediate blast was not the killer. The killer was the atmosphere. The impact blasted trillions of tons of pulverized rock, glass, and soot into the upper atmosphere. This cloud spread around the globe in days, wrapping the earth in a suffocating shroud. The sun vanished. For months, perhaps years, the planet was plunged into a deep, cold night. Photosynthesis stopped. The plants died. The herbivores that ate the plants died. The carnivores that ate the herbivores died. The food chain, built on the foundation of sunlight, collapsed from the bottom up. It was the great filter, 75% of all species on Earth were extinguished. The mighty T-Rex, the Triceratops, the long-necked sauropods, creatures that had ruled for 160 million years, starved to death in the cold dark. They were too big. They needed too much food. Their specialization became their doom. But in the ruins of that shattered world, life persisted. Deep in their burrows, protected from the heat and the firestorms, the small mammals huddled. They were scavengers. They could eat insects, roots, rotting flesh, anything. They didn't need much food to survive. Their warm blood allowed them to function in the freezing temperatures of the impact winter. Their nocturnal heritage meant they were not afraid of the dark. When the dust finally settled, when the sun broke through the gray clouds years later, the world had changed. The giants were gone. The silence was profound, but the stage was empty. The tyranny of the dinosaurs was over. The age of mammals had begun. This moment, the KPG extinction event, is the most clearly defined boundary in the history of life. It is a line in the rock. Below it, dinosaur fossils. Above it, mammals. It teaches us a terrifying lesson. Resilience is not about strength. It is about adaptability. It is about being able to endure the worst the universe can throw at you. It also teaches us that intelligence is a child of catastrophe. Without the asteroid, mammals might have remained small, nocturnal shrews forever. We needed the world to break in order to inherit it. We are the phoenix that rose from the ashes of the dinosaurs. As the Cenozoic era dawned, the planet began to recover. The forests returned, but they were different forests, dominated by flowering trees and broad leaves. The mammals, released from the pressure of predation, exploded in diversity. They radiated into every empty niche. Some went back to the water and became whales. Some took to the air and became bats. Some grew massive and became the megafauna, giant sloths, woolly mammoths, saber-toothed cats. But one lineage, a small tree-dwelling group, took a different path. They stayed in the canopy. They were the early primates. Why did we go into the trees? It was likely for safety and for the fruit. But life in the trees requires a very specific set of skills. You cannot smell your way from branch to branch. You need to see. You need to judge distance perfectly. If you miss a jump at 50 feet up, you die. This evolutionary pressure forced the eyes of our ancestors to move from the sides of their heads to the front. This created stereoscopic vision, 3D depth perception. We lost our panoramic view of the world, but we gained the ability to see the world in layers, to understand the geometry of space. This shift in perspective was profound. It allowed us to focus. It allowed us to manipulate objects in front of us with precision. Living in the trees also gave us hands. You cannot climb with hooves or paws. You need fingers. You need to grasp. We developed opposable thumbs, tactile pads sensitive enough to feel the ripeness of a fruit or the texture of bark. These hands were the first tools of consciousness. Before we built telescopes or computers, we manipulated the world with our fingers. This feedback loop between the hand and the brain drove the expansion of the motor cortex. We began to interact with the universe not just as a space to move through, but as a collection of objects to be held, examined, and understood. The climate of the Cenozoic was generally warm and tropical, a greenhouse Earth. Jungle stretched from the equator to the poles. It was a paradise for our primate ancestors. But the universe is never still. The continents continued to drift. India slammed into Asia, raising the Himalayas. This massive uplift of rock exposed fresh minerals to the air, which reacted with carbon dioxide, scrubbing it from the atmosphere. The planet began to cool. The great tropical forests began to shrink. They were replaced by a new, tougher ecosystem. The grasslands, the savannas appeared. This climate shift, beginning around 30 million years ago, set the stage for the next crisis. Our ancestors were safe in the trees, but the trees were disappearing. The gaps between the forests were growing wider. To get from one patch of food to another, they would eventually have to come down. They would have to cross the open ground. This descent from the canopy was the expulsion from the Garden of Eden. It was dangerous. The grass was tall, hiding predators like big cats and hyenas. We were slow, weak, and defenseless on the ground. But we had our eyes, we had our hands, and we had our brains. The pressure to survive in this exposed environment would force the most radical adaptation of all, bipedalism, standing up. We stood up to see over the grass. We stood up to look for predators. We stood up to free our hands to carry food and eventually weapons. But standing up did something else. It aligned our spine vertically. It balanced our heavy head on top of a column of bone. It allowed our brains to grow larger without toppling us over. Consider the improbability of this lineage. We are the descendants of the survivors of the asteroid, the survivors of the nocturnal bottleneck, the survivors of the shrinking forests. Every single one of your ancestors, going back millions of generations, lived long enough to reproduce. None of them were eaten before they passed on their genes. None of them died of disease before having children. You are the tip of a spear of survival that has been thrust through time, overcoming impossible odds. When you feel anxiety or stress or fear, remember that these are not flaws. They are the survival mechanisms that kept your ancestors alive in a world of monsters. You are a biological success story written in the code of DNA. But evolution is not just about survival. It is about information. The universe is learning. Through the eyes of the early primates, the universe learned to see in 3D. Through the ears of the early mammals, it learned to hear the high-frequency squeaks of insects. Through the noses of the nocturnal shrews, it learned to smell the chemical trails of the night. We are the sensory organs of the cosmos, gathering data, processing it, and storing it in the wet network of our neurons. The asteroid that killed the dinosaurs did not stop this process. It accelerated it. It cleared away the old biological hardware, the large reptilian bodies, and replaced it with the compact, high-efficiency, high-processing mammalian model. It was a hardware upgrade for the planetary biosphere. As we approach the end of the age of mere animals and begin the transition to the age of hominids, we must recognize the role of chance. If the asteroid had been slightly larger, it might have sterilized the planet completely. If it had been slightly smaller, the dinosaurs might have survived, and intelligent life might have taken a reptilian form, or never emerged at all. If the Himalayas hadn't risen, the forests might have remained, and we would still be happy monkeys in the trees, never needing to stand up, never needing to build a fire. We are the children of geological and cosmic accidents. We are here because the earth is restless. We are here because the sky fell. There is a deep humility in this realization. We are not the inevitable rulers of this planet. We are the current tenants. We hold the lease because of a series of fortunate catastrophes. The dinosaurs ruled for 160 million years. We have been here in our modern form for only 300,000. We are a blink of an eye compared to them, but in that blink, we have done something they never did. We have looked up. We have dug up their bones and reconstructed their history. We have understood the asteroid that killed them. We have developed the potential to deflect the next one. This is the difference between intelligence and mere survival. Intelligence allows a species to take control of its own destiny, to stop being a victim of cosmic dice and start becoming a player in the game. The path is now open. The trees are thinning. The savanna is waiting. The sun beats down on the open grass, casting long shadows. A strange ape is standing at the edge of the forest, looking out at the dangerous horizon. It is scared. It is vulnerable. But there is a spark behind its eyes. It is calculating. It is wondering. It is about to take a step that will lead to stone tools, to fire, to language, to cities, and, eventually, to the stars. The universe is holding its breath. The experiment of consciousness is about to enter its most volatile and beautiful phase. Have you ever looked at your own hand, really looked at it, and marveled at the machinery of your thumb? Touch your thumb to your pinky finger. That simple motion, that ability to grasp, to manipulate, to hold, is the bridge between the animal mind and the godlike power of creation. It is a legacy from a time when we lived in the canopy, reaching for fruit, but it was repurposed for something far more profound. That hand, which once held branches, would eventually hold the controls of a spacecraft bound for Mars. But to get from the branch to the rocket, our ancestors had to do something terrifying. They had to let go. They had to drop from the safety of the leaves and step onto the dangerous open floor of the world. This is the story of the Great Descent. It is the story of how a changing climate forced a reluctant ape to stand up, walk, and eventually to tame the very energy of the stars. Fire. Imagine East Africa 7 million years ago. It is a lush, continuous rainforest, a green ocean of leaves stretching from the Indian Ocean to the Atlantic. It is a paradise for our ancestors, the early hominids. They are safe there. They have fruit. They have shelter. They have each other. But the earth is restless. Deep beneath the crust, a plume of magma is pushing up, tearing the African plate apart. The Great Rift Valley is forming. This geological scar creates mountains that block the moist winds from the ocean. The rains fail. The forest begins to fragment. Slowly, over millions of years, the green ocean dries up. It becomes a mosaic, patches of trees separated by widening seas of golden grass. The savanna is born. This change in the landscape presented a brutal choice: adapt or die. The fruit was no longer within easy reach. To get from one grove of trees to the next, our ancestors had to cross the open ground, and the ground was ruled by monsters: saber-toothed cats, giant hyenas, and eagles large enough to carry off a child. In this environment, walking on 4 legs, low to the ground, was a death sentence. You couldn't see the predators hiding in the tall grass. You were slow. You were vulnerable. So, under the pressure of survival, a new posture emerged. We stood up. Bipedalism, walking on 2 legs, is a bizarre way to move. It is essentially a controlled fall. It is unstable and slow compared to a galloping gazelle. But it has 2 massive advantages. First, it is incredibly energy efficient. A biped can walk for miles and miles on a handful of calories, far further than a knuckle-walking ape. We became the marathon runners of the animal kingdom, capable of relentless pursuit. Second, and most importantly, it freed our hands. If you don't need your front limbs to walk, you can use them to carry. You can carry food back to a safe place. You can carry your babies, allowing them to be born helpless and develop their brains outside the womb. You can carry sticks and stones. Meet Lucy. She is an Australopithecus afarensis, living about 3.2 million years ago in what is now Ethiopia. She stands just over 3 feet tall. She has a brain roughly the size of a chimpanzee's, but she walks like you. Her pelvis is bowl-shaped to support her guts. Her knees lock to support her weight. She is the bridge. She sleeps in the trees at night for safety, but by day she walks the grasslands, scavenging, gathering, surviving. Lucy is not human, not yet. But looking into her fossilized eyes, we see the first flicker of the human spirit. We see the audacity to stand tall in a world that wants to eat you. We see the beginning of the long walk that will eventually lead out of Africa and populate the entire globe. As the climate continued to dry, the pressure on these bipedal apes increased. Food became scarcer. They had to eat tougher things: roots, tubers, meat. This dietary shift changed everything. Meat is dense in calories. It is high-octane fuel. But to get meat, you need to be a predator, or at least a very effective scavenger. You need tools. About 2.6 million years ago, a profound cognitive leap occurred. An ancestor, perhaps Homo habilis, picked up a rock, but instead of just throwing it, they did something no creature had ever done before. They struck it against another rock. Crack. A flake fell off, leaving a razor-sharp edge. This moment, the creation of the first Oldowan stone tool, was the birth of technology. It sounds simple, but think about the mental processing required. You have to understand the physics of the stone. You have to visualize the tool inside the raw material before you make it. You have to plan into the future. I will make this knife now so I can cut meat later. This is a break from the eternal now of the animal mind. It is the beginning of imagination. With a sharp stone, a human is no longer limited by biology. We don't have claws. We make them from flint. We don't have sharp teeth. We make them from obsidian. Technology is the externalization of evolution. We stopped waiting for our bodies to change and started changing the world instead. With better tools came better food. With better food came bigger brains. It is a feedback loop known as the expensive tissue hypothesis. Brains are incredibly energy hungry. Your brain is only 2% of your body weight, but it consumes 20% of your energy. You cannot support a big brain on a diet of grass and leaves. You need fat. You need protein. As our ancestors ate more meat and marrow, cracked open by stone tools, their guts shrank and their brains grew. Homo habilis gave way to Homo erectus, and Homo erectus was a game changer. They were tall, athletic, and possessed a brain 2/3 the size of yours. They were the first to look truly human, and they conquered the most terrifying force in nature: fire. Before Homo erectus, fire was a force of destruction, a terrifying demon sent by lightning to consume the world. Animals run from fire. It is a primal instinct. But somewhere, perhaps around 1.5 million years ago, a human ancestor did the unthinkable. They did not run. They approached the flames. They captured a burning branch. They fed it. They learned that fire, if treated with respect, could be a servant. This is the Promethean moment. This is the single most important discovery in human history. Fire provided warmth, allowing us to survive in colder climates. It provided protection. A campfire is a wall of light that predators will not cross. It allowed us to conquer the night. Before fire, the setting sun meant fear. It meant hiding. But with fire, the day was extended. We could sit up late. And what do you do when you sit around a fire in the dark? You look at each other. You bond. You tell stories. The campfire was the first school, the first theater, the first church. It was the incubator of language and culture. In the flickering light, watching the faces of our kin, we developed empathy. We developed the ability to read minds, to understand what others were feeling. We became the ultra-social ape. But fire did something even more fundamental. It cooked our food. Raw food is hard to digest. It takes hours of chewing and energy to break down. Cooking pre-digests food. It breaks down proteins, gelatinizes starches, and kills parasites. It unlocks a massive amount of calories that were previously inaccessible. A cooked meal gives you far more energy than a raw one. This surge of easy energy went straight to the brain. Our jaws shrank because we didn't need to chew as hard. Our teeth became smaller. Our brains exploded in size. We are the children of the cooking fire. We are the only species on Earth that cannot survive on raw food alone. We have outsourced our digestion to the hearth. With fire in our hands and stone tools in our belts, Homo erectus did something no primate had done before. They left home. They walked out of Africa. They followed the herds, followed the seasons, followed their curiosity. They crossed the Sinai Peninsula and spread into the Middle East, into Asia, into Europe. We find their fossils in Georgia, in China, Peking man, in Indonesia, Java man. They were the first explorers, the first to wonder what lay beyond the horizon. They faced ice ages and deserts. They adapted to jungles and steppes. They were tough, resilient, and resourceful. They lasted for nearly 2 million years, far longer than we modern humans have been around. They were the pioneers who mapped the world with their feet. But back in Africa, the cradle, evolution did not stop. The lineage continued to refine itself. The brain continued to grow. The tools became more symmetrical, more beautiful. The Acheulean hand axes, shaped like teardrops, show an appreciation for aesthetics. They were not just useful, they were pleasing to the eye. Art was beginning to stir. And amidst this gradual refinement, a new species emerged. Anatomically modern humans. Homo sapiens. Us. We appeared roughly 300,000 years ago. If you saw one of these early humans walking down the street today, dressed in modern clothes, you wouldn't look twice. They had our high foreheads, our flat faces, our chins. But inside, their minds were still sharpening. We were not alone, however. We shared the planet with other humans. In Europe, the Neanderthals, stocky, strong, adapted to the cold, were masters of the Ice Age. In Asia, the Denisovans roamed. On islands in Indonesia, the tiny Homo floresiensis, hobbits, lived in isolation. It was a Lord of the Rings world, with multiple species of intelligent humanoids coexisting. We often think we are the only way to be human. We are just the last ones left. What happened to the others? Why are we the only ones here? There are dark theories of war and genocide, and gentler theories of interbreeding and assimilation. The truth is likely a mix of both. We know from DNA that we carry ghosts within us. If you are of non-African descent, you have Neanderthal DNA in your genome. We didn't just fight them. We loved them. We made children with them. But Homo sapiens had something the others didn't seem to possess to the same degree: a capacity for abstract thought and large-scale cooperation. We could trade over vast distances. We could create symbols, art, jewelry, cave paintings that carried meaning. We could believe in things that didn't physically exist: gods, spirits, tribes, nations. This ability to share a collective fiction, to believe in the same story, allowed us to cooperate in groups of hundreds, then thousands. Neanderthals lived in small family bands. We lived in networks. When times got hard, when the climate shifted, we had friends in the next valley. We had a safety net. This social technology was as powerful as any stone tool. It allowed us to outcompete, outlast, and eventually replace our cousins. About 70,000 years ago, a small group of Homo sapiens, perhaps only a few thousand individuals, left Africa. This was the second great exodus. They carried with them the legacy of the stars, the carbon in their bones, the iron in their blood. They carried the legacy of the earth, the biological resilience of the survivors, and they carried the legacy of the fire, the spark of technology and culture. They walked along the coasts of Arabia and India. They reached Australia by boat, a feat of incredible courage. They pushed into the frozen north of Europe. They crossed the Bering Land Bridge into the Americas. In just a few thousand years, a cosmic blink of an eye, we had colonized the entire planet. Imagine the nights of these early wanderers. The sky was pristine, a dome of infinite stars unpolluted by city lights. They must have looked up. They must have wondered, what are those lights? Are they campfires of the ancestors? Are they eyes of the beasts? The same brain that figured out how to crack a nut was now trying to crack the riddle of the cosmos. Mythology was born. We projected our stories onto the stars. We drew lines between the dots and created constellations, hunters, bears, queens. We made the universe human. We made it familiar. This was the first act of astronomy, not measuring the stars, but naming them. Not understanding their physics, but understanding their poetry. This period also saw the birth of true art. Deep in caves in France, Spain, and Indonesia, our ancestors crawled into the dark, lit torches and painted. They painted horses, bison, lions. They painted their own hands, stenciled outlines blown with red ochre. I was here, those hands say. I existed. I saw the beauty of the world. These caves were not art galleries. They were cathedrals. The act of painting in the deep dark suggests a spiritual dimension, a belief in a world beyond the physical. Consciousness was no longer just about survival. It was about meaning. It was about leaving a mark that would outlast the flesh. As the Ice Age deepened, humanity was tested to its limits. We huddled in caves, wrapped in furs, telling stories around the fire while the glaciers ground the mountains to dust outside. We were few, we were fragile, but we were together, and we were clever. We invented the needle, allowing for tight-fitting clothes. We invented the spear thrower, increasing our range. We domesticated the wolf, turning a rival into a best friend, the first time one species entered into a partnership with another based on mutual affection and utility. The dog guarded the camp. The human provided the food. Together, we conquered the world. And then the ice began to melt. The climate stabilized. The great herds of mammoth and bison began to disappear. The world was changing again, and once more humanity stood at a crossroads. We could continue to wander, to hunt, to live as part of the wild ecosystem. Or we could do something radical. We could stop walking. We could put a seed in the ground. We could build a wall. We could tame the chaos of nature and bring it under our control. The age of the hunter was ending. The age of the farmer was about to begin. This transition, the Neolithic Revolution, is often called the rise of civilization, but it was also a narrowing. We traded the freedom of the open savanna for the toil of the field. We traded the very diet of the hunter-gatherer for the monotony of grain. We traded the egalitarian band for the hierarchy of the city. But in exchange, we got surplus. We got grain silos. We got walls. And most importantly, we got time. Time for some people not to spend every waking hour looking for food. Time for priests to watch the stars and track the seasons. Time for scribes to invent writing to count the grain. Time for the mind to turn inward and start asking the really big questions. So, tonight, look at the flame of a candle or the light of a street lamp. That light is the great-grandchild of the fire Homo erectus caught on the savannah. Look at the walls of your room. They are the descendants of the first windbreaks built on the steppe. Look at the screen you're reading this on. It is a stone tool made of silicon and glass, refined by 1,000,000 years of engineering. You are the product of the Great Descent. You are the ape that stood up, the ape that picked up a rock, the ape that caught the fire. You are the result of a gamble that paid off. The universe forced you out of the trees, and in doing so, it forced you to look at the stars, not through the canopy of leaves, but through the open, terrifying, beautiful lens of total consciousness. The journey is accelerating now. We have moved from the slow rhythm of geology to the fast rhythm of history. The city lights are coming. The writing is on the clay tablet. The pyramids are rising in the desert. The mind of the universe is about to become loud. It is about to start shouting its questions into the void. And you, with your caveman brain and your godlike technology, are the one holding the microphone. Have you ever whispered a secret to someone in the dark? Think about what is happening in that moment. You are exhaling air from your lungs, vibrating a pair of small flaps in your throat, and shaping that sound with your tongue and lips. These physical vibrations travel through the air, hit the eardrum of another person, and are translated into electrical impulses. And suddenly, an image that was in your head is now in theirs. You have performed telepathy. You have transferred a thought across the gap between two minds. This is language. It is the most powerful technology ever invented, far more potent than the stone axe or the fire. For millions of years, our ancestors communicated, but they communicated about the here and now. There is a lion. I am hungry. Run. But about 70,000 years ago, something clicked in the wiring of the human brain. We started talking about things that were not there. We started talking about tomorrow. We started talking about spirits. We started talking about the rules of the tribe. This was the cognitive revolution. It was the moment we stepped out of the food chain and into the realm of the imagination. This ability to speak about the non-existent is what allowed us to conquer the planet. A wolf pack can coordinate a hunt, but they cannot tell a story about the great wolf in the sky who created the moon. They cannot create a law that says, "Thou shalt not eat the rabbit on the full moon." But humans can. We can create fictions, stories that we all believe in. These stories allow strangers to cooperate. If you and I believe in the same God, or the same nation, or the same value of a dollar bill, we can work together even if we have never met. We can build a pyramid. We can build a state. We can build a global economy. The physical reality of the universe, the atoms, the gravity, the stars, was now overlaid with a second reality, the reality of culture. We began to live in a world of symbols. As the last ice age ended, about 12,000 years ago, the glaciers retreated, the world warmed up, the sea levels rose, drowning the old coastlines and separating the land masses. The atmosphere became wetter, richer in carbon dioxide. In the Middle East, in a region we call the Fertile Crescent, the hillsides turned green with wild grasses. There was wheat, there was barley, there were wild lentils and peas. It was a garden of abundance. For thousands of years, our ancestors, the Natufians, gathered these wild grains. They didn't plant them. They just harvested what the earth provided. They settled down in stone houses to be near the food. They were the affluent hunter-gatherers, living the good life. But nature is a trap. By settling down, their population grew. More mouths to feed meant they needed more grain. They couldn't just rely on the wild patches anymore. They had to help the grass along. They started pulling up weeds. They started watering the soil. They started saving the best seeds, the ones with the biggest kernels, and planting them in the ground. Slowly, imperceptibly, over centuries, the relationship changed. We stopped being the gatherers of wheat and became the servants of wheat. We had to clear the rocks. We had to carry the water. We had to guard the fields from gazelles and locusts. We had to work from sunrise to sunset, breaking our backs, destroying our knees, purely to ensure the survival of a grass. From the perspective of the wheat, the agricultural revolution was a massive success. 10,000 years ago, wheat was a wild grass confined to a small part of the Middle East. Today, it covers more arable land than any other plant in history. We are the machines that wheat invented to spread its genes globally. But for the individual human, the deal was questionable. The skeletons of early farmers show they were shorter, sicker, and more stressed than their hunter-gatherer ancestors. They had arthritis. They had cavities from all the starch. They had plague, because living in close proximity to domesticated animals jumped viruses from beasts to humans. Measles, smallpox, flu, these are the gifts of the barnyard. We traded the freedom of the wild and the health of the wanderer for the security of the silo. We traded the quality of life for the quantity of life. But there was no going back. Once the population boomed, you couldn't return to hunting. There wasn't enough wild food left to support the numbers. The trap snapped shut. We were locked into the cycle of the harvest. We were tethered to the land. This fundamentally changed our perception of time. A hunter lives in the present. He hunts today for today's food. A farmer lives in the future. He plants today so he can eat in 6 months. He worries about the rain next week. He worries about the winter. Anxiety became the background radiation of the human experience. We began to hoard. We began to build walls to protect the hoard. We began to create armies to protect the walls. The age of property had begun. Yet, this shift also drove us to look up with new eyes. To be a farmer, you must be an astronomer. You need to know exactly when to plant. You need to know when the rains will come. You cannot guess. You must measure. We built great stone calendars, Stonehenge in England, Nabta Playa in Egypt, to track the sun and the stars. We aligned our temples with the solstices. We realized that the heavens were a clock, a giant, predictable machine that governed the life of the soil. The sky became the domain of the gods, the rulers of the harvest. We began to bargain with the universe. If we sacrifice this goat, will you send the rain? If we build this temple, will you save us from the drought? Religion evolved from the animism of the hunter, talking to the spirit of the bear, to the theism of the farmer, worshipping the gods of the sky and the earth. Consider the mystery of Göbekli Tepe. In southern Turkey, on a hilltop, there stands a series of massive stone circles. T-shaped pillars, some weighing 20 tons, are carved with reliefs of foxes, lions, scorpions, and vultures. They are 11,000 years old, 6,000 years older than Stonehenge, 7,000 years older than the pyramids. They were built by hunter-gatherers, people who had not yet invented the wheel, or pottery, or writing. They had no metal tools. Yet they carved these monoliths and dragged them up a hill. Why? It seems that before we learned to farm, we learned to pray. The need to congregate, to worship, to build a sacred space, may have been the spark that forced us to settle down. We didn't build temples because we had a city. We built a city because we had a temple. The drive for meaning preceded the drive for bread. As the millennia passed, the villages grew into towns, and the towns grew into cities. About 6,000 years ago, in the marshes of southern Iraq, the Sumerians built Uruk. It was the first true metropolis. Imagine walking through its gates. It is a shock to the senses. For the first time in history, 50,000 people are crammed into a few square miles. The noise is deafening, donkeys braying, coppersmiths hammering, priests chanting. The smell is overwhelming. Open sewers, roasting meat, incense, unwashed bodies. It is a hive of activity. But look at the faces. They are strangers. In a tribe, you knew everyone. In Uruk, you are anonymous. This anonymity required a new social technology, the law. We needed rules that were written in stone, literally, to keep us from killing each other. We needed a king to enforce them. We needed a hierarchy. The equality of the campfire was gone, replaced by the pyramid of power, the slave, the peasant, the merchant, the priest, the king. And in the temples of Uruk, something mundane was happening that would change the world more than any war. A temple accountant was sitting with a lump of wet clay. He was counting sacks of barley. It was boring work. Our brains are not designed to remember thousands of numbers. So he made a mark on the clay with a reed. 1 mark for 1 sack. Then he made a symbol for barley. Then a symbol for received. He was inventing writing. It didn't start as poetry. It started as a spreadsheet. It started as a way to track debt and taxes. But once the code was unlocked, it couldn't be contained. Soon we were writing down the names of kings. Then we were writing down the laws. And then a poet named Enheduanna, the first named author in history, wrote hymns to the goddess Inanna. We had found a way to freeze thought. Writing is a form of time travel. It allows a voice to speak long after the throat has turned to dust. It allows knowledge to accumulate. Before writing, if a wise man died, his library burned with him. After writing, his knowledge could be stored, copied, and expanded upon by the next generation. This is the ratchet effect of culture. We don't have to reinvent the wheel every generation. We can stand on the shoulders of the dead, the libraries of Sumer, of Babylon, of Alexandria. These were the external hard drives of the human species. We had outsourced our memory to the clay, and later to the papyrus. But civilization came with a cost. The city is a parasite on the land. It consumes resources and excretes waste. The forests of the Near East were cut down to bake the bricks and build the ships. The soil was salinated by over-irrigation until it turned to white dust. The Sumerians wrote laments about the earth turning against them. We were learning the hard limits of ecology. We were learning that nature is not an infinite well. This pattern, rise, expansion, ecological collapse, would repeat again and again. The Maya, the Romans, the Khmer, all great civilizations that hit the wall of their own success. We are the heirs to this cycle. We are the builders of the newest, biggest city, still wondering if we can keep the soil alive. Let's zoom out again. Let's look at this from the perspective of the moon. For 4 billion years, the night side of Earth was dark. Occasionally, a forest fire would flicker, or a volcano would glow, but mostly it was black. Then, very recently, tiny pinpricks of yellow light began to appear. First, the campfires, then the torches of the cities, then the gas lamps, and finally, the electric grid. Today, the Earth at night is a constellation of its own. The Nile Delta is a glowing lotus flower. The coast of China is a ribbon of light. Europe is a web of gold. We have illuminated the planet. We have signaled to the cosmos that something here is using energy. We have become a Type 0.7 civilization on the Kardashev scale, harnessing a significant fraction of our planet's power. This energy comes from the Earth itself. We burned the forests. Then we burned the coal, the fossilized forests of the Carboniferous. Then we burned the oil, the fossilized plankton of the ancient Jurassic oceans. We are fueling our civilization with the bottled sunlight of the past. We are releasing the carbon ghosts of the Mesozoic to power our internet, our cars, our air conditioners. It is a strange loop. The dead world is driving the living one. But this release of energy has consequences. We are altering the atmosphere again, just as the cyanobacteria did 2 billion years ago. We are changing the thermostat. The ice is melting. The seas are rising. The planet is reacting to us. We are no longer just passengers. We are the drivers, and the road is getting slippery. But amidst the concrete and the smoke, the human mind continued to expand. In the city-states of Greece, on the banks of the Ganges in India, in the courts of China, a new kind of thinker appeared. The axial age began around 500 BC. Buddha, Confucius, Socrates, Lao Tzu, they started asking questions not about how to grow wheat or how to build a wall, but how to be good. What is the nature of reality? What is the purpose of suffering? What is justice? They turned the lens of consciousness inward. They realized that the outer world of matter was mirrored by an inner world of mind. They discovered that the universe was not just out there, it was in here. This is the birth of philosophy, of science, of advanced spirituality. It is the moment when the why caught up with the how. We realized that building a great city was not enough if the people inside it were unhappy. We realized that conquering the world was pointless if you lost your soul. This tension between the material and the spiritual, between the engineer and the mystic, has defined us ever since. We are the species that builds nuclear bombs and writes poetry about the fragility of a cherry blossom. We are a paradox carved in flesh. In the libraries of Baghdad, during the Islamic Golden Age, scholars translated the works of the Greeks and the Hindus. They studied algebra, optics, astronomy. They named the stars Betelgeuse, Rigel, Altair. They kept the flame of knowledge alive when Europe fell into darkness. In the observatories of the Maya, priests tracked the cycle of Venus with an accuracy that rivals modern computers. In the polities of the Polynesians, navigators read the waves and the stars to cross the largest ocean on Earth in open canoes. The human mind was active everywhere, probing the limits of the possible, mapping the physical and the metaphysical terrain. We are now approaching the modern era. The pace is accelerating from a trot to a gallop. The printing press is about to be invented, democratizing knowledge. The telescope is about to be turned to the sky, revealing that the Earth is not the center of the universe. The microscope is about to be turned to the water, revealing the monsters in a drop of rain. The steam engine is about to hiss, promising to liberate us from labor while chaining us to the machine. The story of consciousness is about to become a story of exponential growth. But before we rush into the noise of the industrial age, pause for a moment. Think of the scribe in Uruk, pressing his reed into the clay 5,000 years ago. He is long dead. His city is a mound of dust in the desert. His gods are forgotten, but his writing survives. You can go to a museum and see his receipt for barley. You can connect with his mind across the abyss of time. This is the miracle of the symbolic mind. We are not trapped in our own skulls. We can share our thoughts. We can build a collective brain that spans the globe and spans the centuries. We are a species of time travelers, weaving a web of meaning that holds the world together. Tonight, as you sleep in your climate-controlled room, protected by laws you didn't write, eating food you didn't grow, remember the price that was paid for this comfort. Remember the bent backs of the first farmers. Remember the lost freedom of the hunter. Remember the smoke of the coal fires. Civilization is a fragile gift, a thin veneer over the wild animal beneath. But it is also our greatest achievement. It is the vessel that carries the light of consciousness through the dark. We have built a reef of stone and ideas on the surface of this planet, and, for better or worse, it is our home. The stars are still watching, peering down through the city glow, waiting to see what we will do next. Will we burn ourselves out? Or will we learn to tend the garden we have planted? The clay is wet. The stylus is in your hand. The next chapter is waiting to be written. Have you ever held a piece of glass up to the light and watched how it bends the world? It is a simple thing, a mixture of sand and ash melted together. Yet this humble material became the key that unlocked the prison of our perception. For thousands of years, the human eye was the absolute limit of our reality. If something was too far away to see, it did not exist. If something was too small to see, it was not there. We lived in a middle-sized world, trapped between the microscopic and the telescopic, unaware of the vast kingdoms that lay on either side. But in the 17th century, in the quiet workshops of Dutch spectacle makers, someone had the idea to put two lenses in a tube. It was a simple act, a playful experiment with optics. But when that tube was turned toward the heavens, the universe changed forever. The comfortable, cozy shell of the ancient cosmos, where the earth was the center and the stars were just lights painted on a ceiling, shattered. We were about to discover that we were not the masters of a small house, but adrift in an ocean so vast that it would terrify us before it liberated us. In 1609, a mathematics professor named Galileo Galilei climbed the bell tower of St. Mark's Basilica in Venice. He pointed his modified spyglass at the moon. What he saw should have been impossible, according to the philosophy of the time. The celestial bodies were supposed to be perfect, smooth, divine spheres. But Galileo saw mountains. He saw craters. He saw shadows stretching across deep valleys. The moon was not a god. It was a rock. It was a world, scarred and pitted, just like Earth. Then he looked at Jupiter and saw 4 tiny stars dancing around it. This was a heresy written in light. If moons could orbit Jupiter, then not everything orbited the Earth. The center could not hold. In a few nights of observation, the Earth was demoted. We were spun off our pedestal and sent careening around the sun, just another planet in the cold dark. This realization was a trauma for the human ego, but a triumph for the human spirit. It forced us to grow up. It forced us to accept that the universe does not revolve around us, neither physically nor metaphorically. But the lens worked both ways. While Galileo looked up, others looked down. Robert Hooke and Antony van Leeuwenhoek turned their lenses on drops of water, on cork, on blood. They found monsters. They found entire civilizations of animalcules swimming in a tear. They found that life was built of tiny, self-contained rooms they called cells. Suddenly, the human body was not just a vessel for the soul. It was a galaxy of its own, populated by trillions of living entities. The scale of our existence stretched in both directions, outward to the infinite and inward to the infinitesimal. As the Enlightenment dawned, the chaos of the medieval world began to give way to the order of mathematics. A quiet, solitary man in England, Isaac Newton, realized that the same force that pulled an apple from a tree was the force that held the moon in its orbit. He connected the terrestrial with the celestial. He showed that the universe was not governed by the whims of capricious spirits, but by rigid, predictable laws. Gravity, motion, calculus. The universe was a clockwork mechanism, and the human mind could understand its gears. This was a profound shift in consciousness. It meant that the cosmos was intelligible. It meant that if we knew the position and speed of every particle, we could predict the future. We began to feel like masters of nature rather than its victims. But seeing the machinery of the universe was not enough. We wanted to know what it was made of. For centuries, we thought light was just brightness, pure, white, indivisible. But Newton passed a beam of sunlight through a prism and revealed the rainbow hidden inside. He showed that white light is a symphony of colors. Later, scientists discovered that this spectrum was broken by dark lines, missing frequencies. These were barcodes. Each element in the periodic table absorbs light at specific frequencies. By reading these barcodes, we could tell what a star was made of without ever touching it. We could look at a light shining 1,000,000 light years away and know that it contained hydrogen, helium, calcium, iron. We realized that the stars are made of the same stuff as us. We are not separate from the heavens. We are chemically identical to them. The iron in your blood is the same as the iron in the heart of a distant sun. While the astronomers were mapping the sky, the geologists were reading the rocks. They looked at the layers of sediment in cliffs and canyons and realized that the biblical timeline of a few thousand years was impossible. The earth was old, deeply, staggeringly old. It had to be, to allow for the slow erosion of mountains and the gradual evolution of life. This discovery of deep time was as disorienting as the discovery of deep space. It meant that human history was just a flicker at the end of a long, long day. It meant that we were latecomers to our own planet. This humility was necessary. It prepared us for the revelation of evolution, that we were not molded from clay by a divine hand, but forged from biology by the slow, blind process of natural selection. Then came the hunger. The mind was expanding, but the body of civilization needed fuel. We had cut down the forests. We had dammed the rivers. We needed more energy. We found it underground. We dug up the black rocks, coal, and the black sludge, oil. We released the solar energy that had been trapped in the Carboniferous forests and the Jurassic oceans. We invented the steam engine. We invented the internal combustion engine. We turned the heat of the past into the motion of the present. We electrified the night. This was a planetary metabolic shift. Earth began to glow. We wired the continents with copper nerves, transmitting thoughts at the speed of light. We built a second skin for the planet, a skin of concrete and steel and data. But the universe had one more curveball to throw us. At the start of the 20th century, the clockwork universe of Newton began to break down. A patent clerk named Albert Einstein realized that time and space were not absolute. They were relative. They could stretch. They could shrink. Gravity was not a force, but a curvature in the fabric of space-time. If you move fast enough, time slows down. If you stand near a massive object, time slows down. Reality was plastic. And at the subatomic level, things were even weirder. Quantum mechanics showed us that particles could be in two places at once. It showed us that the act of observation changes the outcome. It suggested that at the bedrock of reality, the universe is not made of hard little balls of matter, but of probabilities, of waves, of potential. The solid world dissolved into a dance of energy. In the 1920s, a man named Edwin Hubble sat in a cold observatory on Mount Wilson looking at a fuzzy smudge called the Andromeda Nebula. For centuries, we debated what these nebulae were. Were they clouds of gas nearby? Or were they island universes far away? Hubble found a special type of star in the smudge, a Cepheid variable, which pulses like a lighthouse. By timing its pulse, he could calculate its distance. The answer was shocking. It was not a cloud. It was a galaxy. It was millions of light years away. In that single moment, the universe grew from a single galaxy, the Milky Way, to a cosmos of trillions of galaxies. And not only were they far away, they were running away. The universe was expanding. It had a beginning. It was not eternal. It was born in a big bang, and it was rushing toward a cold, dark future. This is where we stand today. We are the species that knows. We know about the Big Bang. We know about the black holes. We know about the DNA. We have built machines that can leave the gravity of Earth. We have walked on the moon. We have sent robot eyes to the plains of Mars and the rings of Saturn. We have telescopes like Hubble and James Webb that can catch photons that have been traveling for 13 billion years. We are the eyes of the universe. We have woken up. But this knowledge comes with a heavy burden. We know that the sun will eventually die. We know that the earth is fragile. We know that we are alone in the immediate neighborhood. The silence of the stars is deafening. We have scanned the radio waves for decades, listening for a whisper, a signal, a hello from another civilization. So far, nothing. Just the hiss of the Big Bang and the crackle of dying stars. This silence, the Fermi paradox, haunts us. Are we the first? Are we the last? Or are we just too primitive to hear the conversation? Consider the Voyager probes, launched in 1977. They are now leaving the solar system, traveling into the interstellar dark. They carry a golden record, a phonograph with the sounds of Earth. Whale songs, a kiss, the wind, greetings in 55 languages, the music of Bach and Chuck Berry. It is a message in a bottle thrown into the biggest ocean of all. It will likely outlast the Earth itself. Long after our cities have crumbled, long after the sun has swallowed the planet, that little golden disk will still be drifting between the stars. A testament that once, on a small blue rock, there was a species that felt, that loved, that created music. The journey of consciousness has led us to this precipice. We have climbed out of the mud, stood up, learned to speak, learned to write, learned to split the atom. We have mapped the cosmos from the quark to the supercluster. But we are still vulnerable. We are still aggressive, tribal, and short-sighted. We have the technology of gods, but the wisdom of cavemen. The next chapter of our story will not be written by biology. It will be written by our choices. We have reached the point where we can destroy ourselves, or we can transcend our limits. We can stay here and die with the sun, or we can spread the seed of consciousness to the stars. The telescope has shown us a universe of unimaginable violence, colliding galaxies, exploding stars, hungry black holes. But it has also shown us a universe of beauty, the pillars of creation, the sombrero galaxy, the great red spot. It has shown us that we are part of a grand, unfolding process. We are not accidents. We are the universe becoming aware of itself. When you look through a telescope, the universe is looking back. When you study the laws of physics, the universe is understanding its own rules. So, tonight, if you can, go outside. Find a dark spot. Look up. You are not looking at a roof. You are looking into an abyss that has no bottom. You are looking at the past. The light from those stars left them years, centuries, millennia ago. You are time-traveling with your eyes. Feel the spin of the Earth. Feel the rush of the galaxy moving through space at over 1,000,000 miles per hour. You are on a spaceship. We are all astronauts. The only difference is that some of us know it, and some of us are asleep. We have spent the last few thousand years waking up. We have rubbed the sleep from our eyes. We have lit the lamps. We have read the instructions written in the atoms and the stars. Now we are awake. The nursery is getting too small. The cradle is rocking. The horizon is calling. The final frontier is not space. It is the future. It is the question of what we will become. Will we be the caretakers of life? Will we be the architects of new worlds? Or will we be a brief flash in the pan, a moment of brilliance before the darkness returns? The universe is vast, cold, and mostly empty. But in this corner, on this rock, it is warm, it is loud, it is thinking. That is a precious thing, that is a rare thing, and it is up to us to keep the flame alive. The glass that Galileo polished is now a mirror. We look into the cosmos and see our own reflection. We see our potential. We see our fragility. And we see our destiny. Have you ever sat in a room so quiet that you could hear the high-pitched hum of your own nervous system? It is a sound that isn't really a sound, but a vibration of life, a whisper of the electricity that defines you. We have spent this journey traveling outward, past the moon, past the sun, to the edges of the visible universe. We have looked at the macrocosm of galaxies and the microcosm of atoms. But there is one place we have not yet explored, and it is perhaps the most mysterious place of all. It is a universe that you carry with you every moment of every day. It is a universe contained within a shell of bone, floating in a bath of cerebrospinal fluid, hidden in the absolute darkness of your skull. It is the human brain. If the universe is a vast ocean of matter and energy, the brain is the island where that ocean wakes up and realizes it exists. It is the only object in the known cosmos that can contemplate its own origin. And the story of how 3 pounds of wet, gray jelly became the seat of consciousness is the final and most intimate chapter of our cosmic history. Consider the sheer improbability of your own mind. You are made of atoms that were forged in the hearts of dying stars. These atoms do not think. A carbon atom is not conscious. An iron atom does not feel pain. A hydrogen atom does not fall in love. And yet, when you arrange these atoms in a specific, incredibly complex pattern, when you string them together into proteins, build them into cells, and weave those cells into a network of 86 billion neurons, something magical happens. The lights come on. The eye emerges. You become a witness to the universe. This transition from dead matter to subjective experience is called the hard problem of consciousness. Science can explain how the eye processes light, how the ear processes sound, how the nerves send signals. But it cannot yet explain why that processing feels like something. Why is the color red an experience and not just a wavelength? Why is the sound of a cello sad? This is the ghost in the machine. This is the alchemy of the mind. To understand this inner galaxy, we must look at its geography. The brain is not a single lump of tissue. It is a landscape of mountains and valleys, folded in upon itself to fit inside the skull. If you were to flatten out the cerebral cortex, the wrinkled outer layer where thinking happens, it would cover the size of a large pizza. This folding is a trick of evolution, a way to pack more processing power into a small space. The terrain of the brain is divided into territories, each with its own function, yet all interconnected in a web of incredible density. There is the visual cortex at the back, processing the photons that hit your retinas. There is the auditory cortex on the sides, deciphering the vibrations of the air. There is the motor strip across the top, controlling the puppet strings of your muscles. And deep in the center, buried beneath the folds, are the ancient structures, the reptilian brain, the limbic system, that govern our breathing, our heartbeat, and our primal emotions. You are a walking museum of evolutionary history. Your brainstem is a legacy of the first fish. Your limbic system is a legacy of the early mammals. Your cortex is the crowning glory of the primates. You are not one mind. You are a council of minds arguing and collaborating in the dark. Imagine shrinking down to the size of a photon and entering this inner space. You would find yourself in a dense forest. But instead of trees, you're surrounded by neurons. These are the most complex cells in nature. They look like lightning bolts, frozen in gelatin, with long, branching tendrils reaching out to touch thousands of their neighbors. The forest is not silent. It is crackling with storms. Every thought you have, every memory you recall, every movement you make is a cascade of electrical impulses racing down these branches at 200 miles per hour. These are action potentials, tiny spikes of voltage generated by the movement of sodium and potassium ions, salt, across the cell membrane. It is a chemical dance. It is the ocean inside you, remembering how to move. The connections between these neurons are the true miracle. A single neuron can have up to 10,000 connections, or synapses with other neurons. If you do the math, the number of possible connections in your brain exceeds the number of stars in the Milky Way. In fact, it exceeds the number of atoms in the known universe. The complexity is staggering. This web of connections is not static. It is alive. It is constantly changing. Every time you learn something new, a synapse grows stronger. Every time you forget, a synapse fades. This is neuroplasticity. Your brain is physically rewriting itself in real time, sculpting its own structure based on your experiences. You are not the same person you were yesterday because your brain is not the same brain. You are a flowing process, a river of information that never stands still. But where is you in this forest? Where does the self reside? For centuries, philosophers thought there was a homunculus, a little man inside the head, watching the movie of reality. But modern neuroscience tells us there is no little man, there is no center, there is no CEO office in the brain. Consciousness is not a thing, it is a performance. It is the result of millions of neurons firing in synchrony, a murmuration of starlings that creates a shape in the sky. When you are awake, the brain is in a state of controlled hallucination. Your senses take in a tiny fraction of the information available in the world, a sliver of the electromagnetic spectrum, a narrow range of frequencies, and your brain fills in the rest. It predicts what it expects to see. The world you perceive is a simulation, a model constructed by your cortex to help you survive. You are not seeing reality as it is. You are seeing a user-friendly interface designed by evolution. Think about the mystery of sleep. For 1/3 of your life, you lie down, close your eyes, and disconnect from the physical world. Your muscles are paralyzed. Your sensory inputs are dampened. You are vulnerable. In the wild, this is a dangerous thing to do. So why do we sleep? It turns out that sleep is the maintenance cycle of consciousness. When you sleep, your brain cells actually shrink, opening up spaces between them. A fluid washes through these spaces, flushing out the metabolic toxins that accumulate during the day. Sleep is a shower for the brain, but it is also a time of consolidation. The hippocampus, the part of the brain that stores short-term memories, uploads the day's events to the cortex for long-term storage. It weaves the new information into the old tapestry of your identity. And then there are dreams. Dreaming is the universe playing with itself. It is the brain running simulations without the constraints of physics. In a dream, you can fly. You can talk to the dead. You can be in two places at once. This is the creative engine of the mind, shuffling memories and concepts to find new patterns. Some theories suggest that dreaming evolved to help us practice for threats, to run what-if scenarios in the safety of the night. Others suggest it is just random noise, the static of the brain clearing its cache. But anyone who has woken up from a vivid dream with a profound sense of emotion knows that it feels meaningful. It feels like a journey into a deeper layer of reality. The emergence of this inner universe has changed the outer universe. For billions of years, the cosmos was a play without an audience. Stars were born and died. Galaxies collided. Planets formed. But no one saw it. No one felt the heat. No one admired the beauty. The universe was senseless in the literal meaning of the word. But with the arrival of the brain, the universe grew eyes. It grew ears. It grew a heart. Through us, and perhaps through other beings on other worlds, the cosmos has developed the ability to reflect on itself. We are the mirrors of creation. When you look up at the Milky Way, it is not just a human looking at a galaxy. It is the galaxy looking at itself through the lens of a human eye. This loop, matter creating mind, mind observing matter, is the fundamental circle of existence. But this consciousness is fragile. It is dependent on a delicate balance of chemistry and electricity. A slight change in oxygen levels, a few drops of a chemical, a physical trauma, and the self can dissolve or distort. We see this in conditions like Alzheimer's, where the library of the self burns down one book at a time. We see it in strokes, where a part of the world simply vanishes from perception. This fragility reminds us that we are biological machines, tethered to the laws of physics. We are not spirits floating in a void. We are anchored to the flesh. And yet, this flesh is capable of transcendence. It can write symphonies. It can solve equations that describe the curvature of space-time. It can feel compassion for a stranger. One of the most profound discoveries of recent neuroscience is the default mode network. This is a set of brain regions that light up when you are doing nothing, when you are daydreaming, worrying, thinking about the past or the future. This is the home of the ego. It is the storyteller that constantly narrates your life, saying, I am this, I want that, I remember when. Oh, but interestingly, when people enter deep states of meditation or have profound psychedelic experiences, this network goes quiet. The ego dissolves. The boundary between the self and the world fades. People report a feeling of oneness with the universe, a sense that the I was an illusion all along. Perhaps this is a glimpse of a deeper truth. Perhaps the feeling of separation, of being a passenger in a body, is a necessary trick for survival, but not the ultimate reality. Perhaps, at the fundamental level, there is only one consciousness shining through billions of different windows. As we look to the future, the story of the brain is taking a new turn. We are beginning to merge with our technology. We are building interfaces that allow the brain to control computers directly. We are treating deafness with cochlear implants that wire sound directly into the nerve. We are experimenting with chips that can restore memory. The line between the biological and the digital is blurring. We are also building artificial minds, neural networks made of silicon that mimic the architecture of the brain. These AIs are learning to speak, to paint, to solve problems. Are they conscious? Not yet, perhaps. But they are asking the question. They are holding a mirror up to us and asking, what makes you so special? The existence of the brain poses the ultimate question. Is consciousness a fluke, an accidental byproduct of complexity? Or is it a fundamental property of the universe, like gravity or electromagnetism? Panpsychism is the ancient idea that consciousness is woven into the fabric of reality, present in some tiny, primitive form in every particle. If this is true, then the human brain is not a generator of consciousness, but a receiver. It is an antenna tuned to the frequency of the universal mind. It gathers the diffuse awareness of the cosmos and focuses it into a sharp, coherent beam. I am. Think about the silence of the brain. Inside the skull, it is pitch black. There is no light. There is no sound. There is only the wet, rhythmic pulsing of blood and the silent flash of chemistry. Yet, out of this sensory deprivation tank comes the technicolor movie of your life. It creates the blue of the sky, the warmth of the sun, the melody of a song. It creates the feeling of love and the sting of grief. It is the ultimate virtual reality machine, and you are the user, the player, the ghost in the shell. You are the universe, waking up from the dream of matter and entering the dream of mind. This journey inward is just as vast as the journey outward. We have mapped the continents of the earth and the constellations of the sky, but the map of the connectome, the wiring diagram of the brain, is still blank in many places. We are explorers standing on the edge of a new continent, a continent made of thought. The mystery of how objective matter becomes subjective experience is the horizon we are sailing toward. It is the final frontier. And just like the first fish that crawled onto land, or the first ape that looked up at the stars, we are standing on a threshold. We are about to understand what we are. So tonight, as you lay your head down, remember what is inside that pillow. Remember the 86 billion stars that are burning in the darkness of your skull. Remember the trillions of connections that are weaving the story of your life. You are a galaxy of quiet thunder. You are a vessel of stardust that has learned to think. You are the universe's most complex experiment. And as you drift into sleep, consider this. If the universe can wake up in you, where else is it awake? Who else is dreaming in the cosmic dark? The lights are on in the house of humanity, but we are just beginning to look out the windows. The brain is the artifact that connects the beginning of time to the end of time. It remembers the Big Bang in its atoms. It remembers the ancient oceans in its salt. It remembers the dinosaurs in its fear. And it imagines the future in its cortex. It is the bridge. And you, the conscious observer, are the traveler crossing that bridge. The journey is not over. The mind is still expanding. The universe is still thinking. And the next thought it has might be the one that changes everything. Have you ever sat by a dying fire, watching the last embers glow in the ash? There is a particular kind of silence that descends when the flames have gone out, a stillness that feels heavy and final. We have spent this journey exploring the ignition of the cosmos, the roaring bonfires of the first stars, and the steady warmth of our own sun. We have traced the rise of complexity from the simplicity of the Big Bang to the intricate architecture of the human brain. But every story has an ending, and the story of the universe is no different. We are currently living in what cosmologists call the stelliferous era, the age of stars. It is the time when galaxies are bright, when stars are fusing hydrogen, when planets are warm, and when life is possible. But this era is not eternal. It is a brief, brilliant summer in a year that lasts forever. The story of how the universe ends and what happens to consciousness when the lights go out is the final, magnificent perspective we must confront. It is a vision of the deep future that transforms our understanding of the present, reminding us that we are the universe's fleeting moment of awakening. Imagine forwarding the clock, not by years or centuries or even millenniums, but by eons. In about 4 to 5 billion years, our own sun will exhaust its hydrogen fuel. It will swell into a red giant, consuming Mercury and Venus, and perhaps the Earth itself. Our planet, the cradle of all known life, will be returned to the fire from which it came. But this is not the end of the universe. It is merely the end of our local chapter. Across the cosmos, other stars will continue to shine. The Milky Way will collide with the Andromeda Galaxy, merging into a massive new elliptical galaxy often nicknamed Milkomeda. The night sky of that future era will be a dazzling haze of 1 trillion stars, a chaotic dance of gravity that will eventually settle into a smooth, featureless glow. But even galaxies are mortal. The fuel for star formation is finite. Every time a star dies, it locks away a portion of its mass in a dense remnant, a white dwarf, a neutron star, or a black hole. This material is trapped, no longer available to build new generations of suns. Slowly, inexorably, the gas clouds are used up. Scientists estimate that star formation in the universe will effectively cease in about 100 trillion years. That is a span of time so vast that it makes the current age of the universe seem like a single heartbeat. By that time, the last massive blue stars will have exploded long ago. The sun-like stars will have faded into white dwarfs. The only light remaining will come from the red dwarfs, the tiny frugal stars that burn their fuel so slowly they can live for trillions of years. These dim red embers will be the final hearths of the cosmos, the last places where life might cling to existence in a cooling universe. Imagine a civilization living around one of these last red dwarfs in the far, far future. Their sky would be almost black. The distant galaxies would have raced away from them, carried by the accelerating expansion of the universe, until they crossed the cosmic horizon and vanished from view. They would be alone in the dark, huddled around their dying star. They might look at their history books and read about a time when the universe was filled with light, when the sky was crowded with galaxies. They might wonder what it was like to live in the golden age of the cosmos, the age we are living in right now. This realization is profound. We often wish we could see the future, but perhaps the future would look back at us with envy. We are the lucky ones. We are the ones who get to see the universe in its prime, awake and vibrant. As the trillions of years roll by, even the red dwarfs will exhaust their fuel. One by one, they will flicker and go out. The universe will enter the degenerate era. It will be a graveyard of stellar corpses. White dwarfs, neutron stars, and black holes will drift through the endless dark. Occasionally, two of these remnants might collide, creating a brief flash of light, a supernova that illuminates the void for a few weeks before fading back into blackness. But mostly, it will be cold. It will be quiet. The stars that once defined the structure of the galaxies will slowly detach from their orbits, flung out into the intergalactic void by gravitational interactions, or spiraling inward to be consumed by the supermassive black holes at the galactic centers. But even this dead matter is not eternal. In the unfathomable depths of deep time, protons themselves, the building blocks of atomic nuclei, may eventually decay. If this theory is correct, then over a span of years expressed as a 1 followed by 34 zeros, the white dwarfs and neutron stars will dissolve. The solid matter of the universe will turn into a thin mist of radiation. The planets, the asteroids, the dust, everything made of atoms will simply cease to be. The only things left will be the black holes, the silent monsters that have grown fat on the wreckage of the galaxies. They will be the final lords of the cosmos, and then even the black holes will die. Stephen Hawking taught us that black holes are not truly black. They leak radiation. Over timescales that defy human comprehension, a Google years, a 1 followed by 100 zeros, the supermassive black holes will evaporate. They will shrink, atom by atom, photon by photon, until they disappear in a final burst of energy. When the last black hole evaporates, the universe will enter the dark era. There will be nothing left but a diffuse sea of photons and neutrinos, cooling toward absolute zero. The universe will have reached maximum entropy. This is the heat death. It is the state of perfect equilibrium, where no energy can flow, no work can be done, and no life can exist. This vision of the end might seem bleak. It might make you feel small and insignificant. But I want to offer you a different perspective. I want you to see the beauty in this finitude. The fact that the universe has a beginning and an end means that it is a story. And a story is defined by its middle. We are in the middle. We are the characters on the stage during the most dramatic, colorful, and meaningful act of the play. The era of stars and consciousness is a fleeting flowering of complexity between the chaos of the Big Bang and the cold silence of the heat death. That we are here to witness it is a statistical miracle. Think about IC 1101, that colossal galaxy we discussed, with its 100 trillion stars. It will eventually dissolve. Its stars will burn out. Its black hole will evaporate. But right now, it exists. Right now, it is shining. And right now, across the gulf of 1 billion light years, a species of bipedal apes on a small rocky planet has built a machine to see it. We have captured its light. We have measured its mass. We have understood its story. In a universe that is mostly dead matter and empty space, this act of understanding is a jewel. It is the universe waking up to itself. Consciousness, then, is not just a biological accident. It is the universe's way of defying the dark. For a brief moment, matter organizes itself into a form that can feel, that can love, that can wonder. We are the flash of the firefly in the night. The flash is short, yes. It is surrounded by darkness, but it is the only thing that matters. The value of a life, or a civilization, is not measured in how long it lasts, but in the intensity of its awareness. A single moment of understanding, that aha moment, when you grasp a new concept or feel a deep connection, is a victory over entropy. It is a reversal of the cosmic flow toward disorder. We are made of star stuff. The atoms in your hand were forged in the nuclear furnaces of ancient suns. They traveled through space for billions of years. They coalesced into a planet. They cycled through rocks and water and plants and dinosaurs. And now, for a few decades, they are you. They are arranged in the specific pattern that allows you to read these words and think these thoughts. When you die, those atoms will not vanish. They will return to the earth. They will become part of a tree, or a cloud, or another child. And eventually, when the sun dies, they will be returned to the cosmos. You are a temporary pattern in an eternal flow. You are a wave on the ocean of the universe. The wave crashes, but the water remains. As we reach the end of this journey, I want you to return to the room you're sitting in. Feel the gravity holding you to the chair. That is the same gravity that holds the galaxies together. Look at the light in the room. That is the same electromagnetic energy that streams from the stars. Listen to the silence. That is the same silence that fills the voids between the galaxies. You are not separate from the universe. You are not an observer looking in. You are the universe experiencing itself from the inside. Your curiosity is the cosmos seeking to know itself. Your wonder is the cosmos marveling at its own grandeur. The mystery of consciousness, how the brain generates the mind, may one day be solved. We may map every neuron and understand every electrical impulse, but the feeling of being alive, the raw sensation of existence, will always remain a personal miracle. It is a gift that the universe has given to itself, and it is a gift that comes with a responsibility. If we are the eyes of the universe, then we must look. If we are the ears, we must listen. If we are the memory, we must learn. We are the custodians of meaning in a cosmos that is otherwise silent. So, keep looking up, keep asking questions, keep wondering about the stars and the cells and the strange, beautiful logic of reality. The biggest galaxy we have ever discovered is bigger than your imagination. But the fact that you can imagine it at all, that you can hold a model of the infinite in your finite brain, is the most amazing thing of all. The journey of discovery is not over. It is infinite. As long as there are minds to wonder, the universe will have a story. You are the stardust that breathes. You are the gravity that feels. You are the quantum field that dreams. Go gently into the night, knowing that you're exactly where you're supposed to be. Here, now, awake, in the glorious middle of the story.